Hello, everyone. Happy Monday. Welcome to OpenDev virtual event number 2. I am Jonathan Bryce, and I'm here once again with Ashley Ferguson, my co-host for the day. How are you doing, Ashley?
Hello, I'm doing great, Jonathan. How about you?
I'm doing wonderful. It's great to see everybody who's joining in. I saw James Pinnock pop on screen there for a minute, and I see Julia Krieger. It's very early for both of them. Thank you for joining us on the crack of dawn from the Pacific time zone. So this is our second event in the OpenDev virtual event series. Ashley, why don't you talk a little bit about what this event is about, and also what we have coming up the rest of the year?
Yeah, so this event is going to be about hardware automation. This is our second OpenDev event. The last event was large scale usage of open infrastructure software. So we had a lot of great use cases at that event. So we're excited to keep that going. And then we also have a third OpenDev event coming up later in August, and that's going to be around containers in production. And Jonathan, you want to tell them a little bit about our next OpenStack Foundation event later this year?
Yes, so we will be having our next Open Infrastructure Summit in October, and that will be a virtual event. It'll run October 19th to the 23rd, and the CFP is open now, so you can go to cfp.openstack.org if you have an idea for a presentation or a panel or something that you would like to speak about during that event. And it's great to see the ideas that are coming in, but we always want to get as many as possible. So go to cfp.openstack.org before August 4th and submit your proposal through that. And hopefully we will see all of you at the next OpenDev and then also at the Open Infrastructure Summit in October. So for today, let's talk a little bit about how to participate in this event that we're kicking off.
Yeah, so if you were at the first event, you're probably familiar with it by now, but welcome if this is your first virtual OpenDev. So I just wanted to talk through a couple tips of just how to, help this event run as smoothly as possible and help you get the most out of it. So first of all, we're obviously using Zoom, so congrats if you made it here. And then we'll also be using an open source tool that we call an Etherpad. So we'll talk a little bit more about that in a second. So back to Zoom. I'm sure a lot of you are familiar with it, but we will be using the Zoom chat for a lot of our discussion. So if you have any technical questions, feel free to post those in there. We will be monitoring that and we'll be passing questions to the moderators so that they kind of have a better idea of how to direct the conversation and make sure that we get to as many questions as we can. But we also want you to jump into the conversation yourself. So, this is a collaborative event that's based on solving open infrastructure challenges. So we want to hear from all of you and your experience. So feel free to unmute yourself when the time is right and jump into the conversation because we want to hear from you. But if you're not speaking, make sure to keep that on mute just so that we eliminate any background noise because we know virtual events can be a little tricky. And so for Etherpad, so like I said, this is an open source tool that we'll be relying on for most of the event. It's basically just like a big collaborative document online. So we use it for notes, feedback, and different action items. So we'll be dropping links to those in the chat right now. So make sure to check those out. You can also find them linked on the online schedule. And we'll drop that link in as well. So make sure to go check those out. There will be one per day for this event. So make sure to jump in there. And that's also a great place to drop your name and contact information if you're interested in reaching out to people and staying connected after the event. And if you need any help at all during the event, feel free to email events@openstack.org if you need, some tech help, if you have trouble logging in at any point, and we'll have people ready to help you out there. And like I said, if you have any technical questions, we'll be using the Zoom chat for that. So if it's relevant to the topic discussion, feel free to drop it in Zoom. And then we also sent out a tips and tricks Etherpad in some pre-event emails that we will also drop in the chat right now that will have that should answer any other questions that you might have. And just as a friendly reminder, this is an OpenStack Foundation event, so we do abide by the OpenStack community code of conduct. So just as a reminder, please be courteous, conduct yourself professionally, and let's respect each other. And if you need to report any violations of that code of conduct, you can visit openstack.org/code of conduct. That's right at the bottom there, and that will have instructions on how to do that. and I'll turn it back over to Jonathan.
Thanks, Ashley. And I also want to send out a couple of additional thanks. First to our programming committee, Mark, Keith, James, Julia, and Mohammed. They are the crew that put together the topics and the schedule, helped to recruit different speakers and experts to talk about automating hardware and all of the things in the data center this week. So thank you to them for their effort. It's always awesome to have people in our community who step up and help to put these events together. And then I also want to send a thanks to the Platinum and Gold members of the OpenStack Foundation. These OpenDev events are underwritten with the support from our Platinum and Gold members. So thank you to these companies who provide the funding and the sponsorship that lets us throw these events and bring the community together. So that's it for the preamble, and to get us started with the day and help to set the stage and give us some food for thought, I want to introduce the COO of the OpenStack Foundation, Mark Collier.
Thanks, Jonathan. Happy to be here. Good afternoon, good morning, good night. We've got people from all over the world, so just excited to be able to kick off another OpenDev. And I wanted to just start by talking a little bit about why we selected hardware automation. You know, these events are a great way to bring developers and operators together and talk about what's working and what else we need to build together. And so we only did 3 that we had to select this year. And as Ashley said, we had the large scale open source infrastructure recently, that OpenDev, and then we're doing containers in production next. So hardware automation made the cut because it's a really, really important topic right now. There's so much demand for this type of information and technology software to solve this problem. And just to give you a few interesting data points, hopefully, about why we think it's the time to talk about this in a 3-day event. So first of all, there's just continued growth in infrastructure overall. You can see that in looking at the data center numbers. So the data center market continues to grow rapidly. And as those data centers are built out and they continue to grow and new regions are added, those are being filled obviously with compute, storage, and networking. So that alone just indicates that there's a lot more infrastructure that needs to be managed. And if you can manage it through automation, through software, that's definitely preferable. You know, we also see more complexity. So there's an exciting side to this, right? We see things like ARM, where you're getting 30 to 40% improvement in performance per dollar. You have GPUs, which have been on the rise for several years for AI machine learning for performance, and FPGAs you see, you know, being used for inference work and things like that. So it's exciting to see new technologies coming in. They're coming into the data center, some that previously were on the desktop or mobile, but it's also more work. And so, you know, all that hardware that's coming into those data centers, people have to manage those. Human beings are on the other end of the line trying to keep all that gear managed, updated, flashing the firmware, trying to manage the images. So it puts a real burden on the people that actually have to manage all that infrastructure. So it's exciting on the one hand, but it also creates more work for a lot of the people that have to manage all that hardware. And the other thing that's starting to happen is that the places and the types of environments where this infrastructure, all this compute, storage, and networking are going that need to be lifecycle managed and updated with different stacks of open source, you know, it's moving to the edge. So we're not just seeing more data centers, but more types of environments. So that again puts a strain on the people. And that means that we need to have more tools that we can rely on, and not just the tools, but the know-how, the knowledge, you know, sharing those best practices. This is a big part of why we do OpenDev. And I think we're going to see a lot of that this week at the event. Another factor that's really interesting to note is that there's been a shift in a lot of workloads back to on-premises from public cloud. Doesn't mean public cloud is shrinking. Obviously, that's just going to grow and grow and grow. But everything is growing really at this point. And so you see about a doubling in the number of people who are building on-premises private clouds and moving workloads onto those. Sometimes, you know, they've moved them to public cloud and moving them back. So again, this just puts more stress and strain on the people that need to manage all of this infrastructure. So if you're running these exciting higher level services like service mesh or serverless or containerized apps, it's obviously running on physical hardware at some level. And so the people that are having to manage that, they're people we can help by bringing everybody together. So really, these drivers all add up to more scale, more complexity, and more headaches. And at the same time, when I talk to operators out there, I don't get the sense that there are more people. If you see a doubling of the number of environments or the size of environments for on-premises private cloud, for example, I don't think we're seeing a doubling of the teams that need to manage all that hardware. If anything, it's going the other way. So all this points again to the software solutions that are being built to help automate all this work. And there's good news there in that we see more and more communities that are starting to grow. Some of these have been around for years. Some of them are newer in open source to solve these types of problems. And so this is exciting. This shows, again, there's a huge demand for this type of activity. There's a huge demand for solutions in the space. And I think one of the things that we try to do is always bring together different open source communities that are doing similar work. So we've invited people from each of these communities to participate in this week's event, and hope many of them are on right now and can join throughout the week. And a lot of that is, again, making sure we're not duplicating effort, figuring out where we can leverage what we've learned. If there's code that we can leverage that's common, this is a good thing. So these are responses to the demands in the market for this type of automation work. So these are all reasons why we felt like this should be in the top 3 of topics for Open Devs this year. The last stat that I'll leave you with that is an indication of just how much interest and demand there is for this type of software is if you look at Ironic as an example. This was a project that was originally part of Nova, and that's split off within the OpenStack world into a standalone project so more developers could get involved and really focus on this. That was many years ago that it became Ironic. And what's really awesome to see is that we're now getting more code merged per day in Ironic than ever in the history of OpenStack. So this graph really indicates that a lot of people have this set of problems and they want to solve it together. They want to solve it in open source, and they're doing it in a lot of communities. And when you look at OpenStack's Ironic project, this is again another sign that a lot of people want to work together on these problems, which is what we like to see. And so if you look at these two kind of data points, we see a lot of interesting innovation happening in hardware, and we see a lot of rapid progress going into the software solutions in the different open source communities to help people tackle that. However, when I talk to operators, and we see this in the data and the market data and the user survey data that we operate every year, that survey, we see that a lot of people aren't using those tools. A lot of people have created their own in-house tools, or they have their own scripts. They have it written on the back of a napkin. I mean, the actual issue on the ground for a lot of people from a practical standpoint is they're not necessarily taking advantage of all those tools. There's a lot of stuff that was written before they came along, and you feel kind of stuck with it. So one of the questions we have to ask ourselves is, what exactly is holding back the adoption? Because we've got the hardware, we've got the software, and sometimes I think as technologists, we think that's it, our job's done. We built some technology, problem solved. But we know that that's not really the practical reality in the real world. So a lot of what we need to share beyond just lines of code and hardware is practical knowledge, and that's what this event is all about. We have a number of people that are here that talk about how they've adopted these tools. And if you haven't yet adopted one of these standardized tools for managing your hardware and your data center, that's okay. That's okay. You're not alone. That's actually the most common scenario, is for someone to not yet have picked a standard tool and to have something they wrote in-house or just kind of a series of scripts. So that's very, very common. And what we're trying to do is bring together people to share a lot of this knowledge, so that it's not just about expecting another feature in one of these tools to move the needle on adoption. We actually need to help people And we also can document some of the gaps. So when we look at the tools, there may be cases where we need to add more support for certain hardware, certain features. So we'll get those conversations going this week. And, really, I think this quote is one of my favorites. It kind of sums up the scenario that I see playing out often in the technology world, where we sort of think that we've built something and therefore it solves a problem. And, in the real world, of course, there is a giant gap between theory and practice. And so that's what we try to do, is bring together communities of practice around a specific problem domain at OpenDev. So that's what we're here to do this week. And when you think about these communities of practice, it's all about the people. And so we have a lot of people from a lot of different organizations that are going through this experience of building the software, operating the software to automate their data center, automate the hardware in the cloud environments and edge environments. And this is an impressive list of companies, but of course, it's not really about companies, it's about people. So I would encourage you to get to know the people behind the names. Some people think that corporations are people. I don't really subscribe to that. I think people are people. So let's meet some of those people this week and talk about what we can learn together and share that knowledge, not just the code, but the knowledge. We have people from over 200 companies and 55 countries. So that's a lot of diverse experience and knowledge. And so let's get to know each other. I know we're in a virtual environment, it's a little different, but I think we can do it. We had a lot of success in the first OpenDev virtually, so we can do it here again. And so in terms of where a lot of this work goes on, this work beyond the code, I think obviously OpenDev, you're here, so you're in the right place. But there are also a lot of SIGs. This is just a partial list, a couple of SIGs to mention. We can drop links in the chat so you can learn about it later or join up. The multi-architecture SIG, this is obviously a hot topic these days, and trying to figure out what type of work needs to go on to support new architectures in the data center, as I said, are moving from desktop or mobile into the data center at a rapid pace. So that's what that SIG is all about. And then, of course, the bare metal SIG. So these are both within the OpenStack community, but they're also welcoming of anybody working with any tools out there. It doesn't have to be OpenStack. So it's really focused on these specific sets of problems and open source software for infrastructure. Everybody's welcome. And so one of the things that these groups do is produce documentation beyond the code and some of that practical knowledge sharing. So as an example, the bare metal SIG just published some new documents, I believe today, in fact. And to tell us about it, I want to welcome Julia Krieger.
Thank you, Mark. Well, about a year and a half ago, the bare metal SIG, and ultimately the larger community, decided to tell its story. Why bare metal is important, why Ironic is important, why making it easy to build the foundations we build our infrastructure upon is so important. But most importantly, they embarked on this journey in order to spread the word of how they use the tooling to make not only their lives better, but improve their infrastructure and ultimately the world.
That's great. Well, thank you so much. So this information that you've all published, where can people find this, the white paper and more information about it?
The white paper can be found on openstack.org/bare metal or on the new website, ironicbaremetal.org.
Great, thank you so much. Well, this is a perfect example of people coming together and sharing that knowledge. This white paper is very extensive. I definitely recommend everybody check it out and also get involved in the SIG. Check out the new Ironic website. Got the URLs here. We'll drop them in the chat and you can see a little screenshot. So trying to get that knowledge out there, and we'll be doing that throughout this whole week with all of your help. So with that, I just want to say again, welcome to the second OpenDev of 2020 on hardware automation. And I'm going to turn it back over to our co-hosts, Ashley Ferguson and Jonathan Bryce, to take us away. Thank you.
Thank you, Mark. That was a great opening for the day. And what we will be doing for the rest of the day is having those interactive discussions that Ashley was talking about. The morning is going to be broken up into two segments covering the provisioning lifecycle for bare metal. And we'll start out with Mohammed moderating the first section and James taking the second section after a short break. But before we get to that, Ashley, could you tell us about what the topics are for the next 2 days?
Yeah, absolutely. So Jonathan covered today's topics, but definitely make sure to come back Tuesday and Wednesday because we'll be discussing consuming bare metal infrastructure for provisioning cloud-based workloads tomorrow. And then on Wednesday, we'll be talking all things networking. And then also on Wednesday, something that's very important to this event and kind of makes it what it is the wrap up. So that's basically a shorter segment where we kind of talk about next steps and how to keep and stay involved in the future. And a lot of those ways are through the SIGs that Mark mentioned earlier. So we'll be covering sort of summaries from the week and key takeaways, but also some key challenges that maybe we still have some work to do on. So make sure to stick around for that wrap up as well.
And with that, I think that we can go ahead and dive into the first topic. So we will hand it over to Mohammed to lead the discussion and get us started. Take it away, Mohammed.
We're going to get started about talking about hardware automation. So we have up here, Kendall just shared their screen. It keeps flopping back and forth, but hopefully we'll get the screen spotlighted and we'll have the screen shared in front of everyone. So if you're looking to actually participate in the conversation and on the Etherpad, I suggest opening the link that we posted earlier in chat. I guess we can share that again as well. Otherwise, if you're just looking to follow the conversation, you can also do that by having the Etherpad open in front of you. I'd really like to ask everyone who's here to fill in their information, just so that we know who's actually in here today. And don't worry, we're not selling this. No one's going to contact you to buy some hardware automation software after this. The other thing is, please put in a little star next to your name if you're interested in participating in the conversation. It'll be really nice and helpful to have more input because this is a conversation and a discussion. It's not really a one-way kind of panel. So the more people that we have involved, I think the more productive this entire conversation will be overall. So to start off, our first topic is pretty much end-to-end hardware provisioning lifecycle for bare metal. So to kind of give a brief introduction for this subject, we all, there's a whole process that we have from going from the day you decide to buy some hardware until the day that it's running your production applications. And so that there's a whole set of things that happen inside all of that workflow. And I think that there's a lot that all the different individuals that are running data centers at different scales have different experiences that they could share together about how we can do this more efficiently. And so I have jotted down a few interesting subjects to kind of start and spark up the conversation. And I guess the first one that I had, which is something that's common and probably shared across all of the different users, regardless of your scale, is having a system to manage, your data center infrastructure management, your assets, your IP addresses, configuration management, all that other stuff. So I wanted to start off and maybe ask if someone is interested in sharing on, how they go about dealing with this inside their organization, and what are maybe some of the things that they wish they could, do better, or some of the things they like about the way that they do it, and maybe just to share how you currently do this inside your environment. Usually we need one person to start volunteering, and then we'll get the conversation going. So
I could.
Sorry, I was gonna say, we also flipped the question on its head a little bit, and if you have not done any of these things and you're still using spreadsheets, why not? Why have you not looked at automation? Because that's a really good piece of information for everyone to take away to understand what is preventing it and what we could possibly do to improve things or make it easier to consume or easier to adopt.
Yeah.
James, you want to share something?
Sure, yeah, I can kind of kick off with just talking a little bit about how our stuff works at Verizon Media. Because there's like a lot here, so I could ramble for hours on just how our stuff works. So I'll try and keep it brief, but we have an operational asset database. So all assets deployed in the data center go into that database. And right now, there are some, there is some automation there. It's not automated to the degree that we would want to see that happen. So when all hardware enters our facilities, we actually have our on-site personnel or site ops personnel. They actually have little hand scanners now, so they can go through and they can scan the asset tags. We work with our vendors to put asset tags on the cabinets for us. And so our site ops people can go through and scan those asset tags, and that actually associates it with the MAC address and all the other information that was sent to us previously by the vendor. So cabinets come in, already have asset tags on them. We've already received digitally some form of information about like all the MAC addresses that we're going to see in that cabinet, as well as all the asset tags. So when our site ops people go and they scan that, they know, okay, this is rack number whatever. And as they scan each host, it actually starts going and updating that operational asset database. Sort of. There's a couple extra manual steps in there. This is a pretty imperfect process because different vendors put different stickers in different places. So like some have a little thing you can pull out and the sticker, like the MAC address barcode will be on that. But it all depends on who built the machine that day. So we have some where that little pull-out thing doesn't have anything on it, and they went and put the MAC address sticker underneath the lid of the machine. So when that happens, we have to pull out the machine, flip up the lid, find the sticker. You know, it could be on the side, it could be on the top, it could be inside the box, it could be anywhere. But so they go through, they scan that, it all goes into the asset database. And then from there, there's this other long chain of events that kick off in terms of, you know, the network team provisioning the switch, making sure that's configured correctly. The same asset database has a separate set of tables for subnet and supernet information globally. There's an entire different network management system just for provisioning those subnets and pushing them out to switches. Configuration management is like yet another thing. So all of these things exist kind of in separate pieces for us. And then there's some other orchestration tooling that sits on top of them, sort of stitches that data together. It definitely all works fairly well. And actually that asset database acts as the source of truth for Ironic. So for us, hardware comes into the data center, it gets scanned. It then goes through a series of tests. Our site ops people run a script that goes and it tests the hardware and make sure that all the information we need in the asset database is there. They make sure that they can boot the thing. And then once it's done, it gets sent over to Ironic. And so then we have a script that intakes it into Ironic, runs it through, well, what we call cleaning. We backported cleaning into the version of Ironic we have, which is basically we just install a version of Linux on there. And once that's all said and done, it's up and it's ready to go and it's ready for someone to use. And then we handle quota provisioning is basically as a separate problem.
Mm-hmm. So that's really interesting. So James, so it sounds like, you know, you and your team operate at a rack level scale. Not a single server doesn't show up to your, most of the time what it sounds like. You get a whole rack of servers right off the bat.
Yeah, it's usually cabinets at a time, but we do also have hardware that we call just sort of loose, which is if a team just needs like 1 or 2 machines or something like that, then or really if they're replacing a machine, then our setups people will go and just install a single server into a rack somewhere. but whenever possible, they tend to do entire cabinet builds.
Yeah. So then I want to take that, and I think that's a really interesting process that you shared with us. But I wonder if there's someone here that works at maybe at a scale where they work, let's say, on a machine scale, or for example, they get a pallet of servers and not a full pre-set up rack, and maybe someone can share how they work with on a more individual server basis. You know, is there any workflows that you find kind of interesting about what James had kind of proposed, or any differences in maybe how you would do something like this?
So I can speak from my past in data center operations, and basically what James was talking about was kind of like the holy grail of site ops, and being able to go barcode scan the machines and know that they're there and be able to assert that. Because when you start dealing with those things, you also kind of have to deal with capital asset inventory as well, and reporting that and paying taxes on that equipment too, at least if you're in the United States. So all that would have been great 10 years ago for me, and it would have made my life so much easier. Unfortunately, I don't have a time machine.
Yeah, cool. Okay, so go ahead, James.
I was going to say, you know, something we have, we also have like on-site factories for doing cabinet integrations, which is when we actually are getting pallets of gear and assembling them. I was wondering if anyone else kind of did that, if they had sort of like an on-site factory, or what they call a factory, right, where they're integrating cabinets themselves. If they have, it'd be cool to hear like what you're saying about if anyone just has a current process they're doing that they're willing to share.
Yeah. So to chime in on my side, we usually have cabinets already in the data centers, and so we don't necessarily bring the cabinets directly, but we work with system integrators that kind of ship systems that are all kind of pre-integrated, and then we kind of just rack and stack everything inside these data centers. And obviously, there's nice things and there's, you know, not ideal things in doing this. And so when we're doing something like this, the nice thing is we work with a solid integrator that does help and bring a lot of what you mentioned earlier, which is we can get a digital record of everything that's coming in with all the MAC addresses and all the information, which is really tremendous help. I suggest anyone that kind of works with acquiring hardware to work with your vendor and just say, hey, can I have this ahead of time? It's really useful because, you know, spending an hour trying to figure out why this machine won't boot, and it's because someone made a typo in the MAC address, or nowadays, what's interesting is if you have an integrator that's based out of California, I think recently passed a law where they're not allowed to have kind of like, they need to have secure by default values. And so now we no longer have like admin root Calvin. They actually have to ship servers out with randomized passwords. And I think that brings another challenge, because now you have like another step of actually needing to have all those credentials. And, you know, usually they're like on a sticker somewhere on the machine, but, you know, you really want those in a digital record so you can go and enroll these into whatever system that you need to use. And sharing passwords is, you know, copying those over when you're getting, you know, hundreds of machines isn't exactly what you want to be doing. I noticed also, I see some people from China Mobile, and I think it'd be really interesting to hear maybe some of the process there, because obviously, you know, you work at such a big scale over there, and it'd be really interesting to hear sort of your use cases or how that all works in your scope there. I don't know if we have them here on the call.
Hello, Mohammed.
Yes, hi.
Yes, my name is Xiao Guang. I come from China Mobile. Now, because I give some use case about China Mobile's NFV network cloud. In our NFV network cloud, about 50,000 servers involved in this project. So the major problem for us is about the hardware integration, because the huge scale. So it's hard for us to do some manually work as traditional. So we have to do some automation integration work to fix the problems. So we build the automation process. The first after we order the hardware machine from the vendors, then we will do some things parallelly. For example, we will do some pre-configuration about hardware. For example, the servers, the switches. We ask our vendors do some pre-configuration according to our hypervisor needs or some automation tools needs. At the same time, we will do some pre-verification in our lab. Of course, at the same time, because as we know, the automation tool based on the standard data. So we will have to build the low-level design standard data at the same time. Of course, when the hardware shipped to the site, they will do some on-site work. After all this work, we will enter into the automation process. First, we will do some automation configuration, include the servers, networks devices. After that, we will do some verification test about the hardware, include the server configuration, switch configuration, and the cable connectivity. After all this works, we will output the verification report. If there are some errors during the above processes, the on-site engineer will do some correction about all the work. So because we have our automation tools, it's the efficiency and the quality is improved significantly. This is the total process for our for China Mobile's practice. Thank you.
That's cool. So I have some, so what you're bringing up is really interesting because I wrote a little bit on that on line 92, and it was about working with vendors and pre-validating servers. And we also got a question on that in the chat. So maybe I want to ask you while you're still here is how much validation do you ask your vendors to do beforehand? Do you ask them to say, like, if you use a specific version of Linux, do they have to install it and validate it before they send it to you? Do they run and burn-in tests? What's the usual interaction with kind of China Mobile and the vendors they buy hardware from?
Before we buy, as you know, we have before we buy the hardwares, we will have some tender files to ask vendors to provide the hardware which will meet our requirements. For example, we ask them to provide the specific hardwares about the some specification. For example, the CPU, RAM, disk, network card, such kind of certain kind of components. We also this is hardware configuration. I will also ask them to provide some software configuration. For example, the BIOS configuration. For example, the NUMA enable, VTX, the power policy and the performance policy, such kind of configuration. Of course, as you know, we will use the automation tool to do some automation work in the next step. So we have to ask our vendors to do some configuration about the automation. For example, we ask them to enable the BMC port LLDP protocol. And we also ask them to enable the DHCP client for their switch management port, such kind of configuration for our automation tools. So this is some rules for vendors' children.
That's interesting. And then, so that's really helpful. maybe James, I want to maybe redirect the question also to you about that we got in the chat, which is requiring vendors to pre-validate servers for specific configs. Do you want to chime in on that? And I can do that after as well.
Yeah, we do have some things like so. We have some agreements with vendors where we ask them to set like BIOS, certain BIOS settings, specifically like make sure that the machines are PXE bootable, just so that we can do something with them as soon as they come into the data center. And so that's one of the things that we ask that they do. There might be some others, but I'm not informed as to what those are. But if there's an opportunity, I'll ask some of the folks at work and see if there's anything they can share. But I know at least we do ask they set certain BIOS settings for us, and do some kind of hardware validation. Otherwise, everything happens once the gear comes in. We go through and revalidate everything once it comes into the data center.
Maybe I can just give an example of what I meant here, because we do. So this is Anne from CERN. So we have something very similar when we buy hardware. We also ask the vendor to like set specific BIOS settings and so on. But we had cases recently where, for instance, we realize only when we hand over the node to users that, for instance, a driver is missing for, I don't know, I think it was an NVMe device, or it was unclear how to do like certain UEFI RAID configurations and boot from these. So I was just wondering if people hit something very similar, because in some cases we only find out when we hand out the hardware to the users, and it would be nice if we have this up front, for instance, have like CentOS 7 validated, CentOS 8 validated, Windows validated, and so on, and like the vendor does that. I was just wondering if people do something like this, or if they like hardware comes and then the validation starts on site.
Yeah, so actually so when we go to buy a new like platform of hardware, we have a performance engineering team that works closely with all of our vendors. And let's say that we're going to buy a new hardware configuration from vendor Foo. They'll first get an evaluation machine shipped in. And then they take that machine and they put it in the local performance testing lab. And so I think there's some things that happen ahead of time where we try and make sure that, like, yes, it's going to have these hardware platforms or these drivers or whatever that are known to work. But then they still go and get at least one evaluation machine, and they actually set it up in a lab on site, and they do a number of tests on it. So they fire it up, they make sure they can image it, and they go through, they run it through like a little test life cycle a few times. They make sure they get an operating system on it. They see, does it actually work? Does it work with our disk image, with our RAM disk environment that we have set up in Ironic. That's something they've just started doing for us.
Right. Now this sounds very similar to what we do. So our team that actually does the procurement of the hardware does something very similar. They get test machines up front, but then there's a little disconnection between the people taking care of the hardware and buying the hardware, and then it goes through for Ironic in our case as well, and then goes to the user, and there's kind of and the Linux team is in between as well. So there's a kind of a slight disconnection between the end user and the ones buying the hardware. So this is one of the problems.
Maybe I can.
Literally the same case for us.
I can also jump in. Hopefully you can hear me.
We can.
Yeah, thanks a lot. So I'm Umar from Schwarz IT. And maybe what Arne is mentioning is hit homes closer to me, because we usually don't get new hardware. We get hardware which was used already. And then there are many things that we need to configure ourselves. And there's no luxury of telling a vendor to do it already for us. So I completely agree. There's a disconnect where maybe I have to set the PXE boot or set it to default because someone who is installing the hardware for me doesn't care about it. So I think there is this gap where making sure that the server is ready for me, I have to go there physically. And that's also quite an important point where I wanted to know what other people do. So I'll just explain it a little bit more. So someone has used the server before, they have maybe manually installed something on it. Maybe they haven't the DHCP enabled for the ILO or for the iDRAC for Dell, for example. And then there's no automated way of going there and resetting it. You have to do it manually. Yeah, so that's a gap which I think cannot be filled yet, but whatever I have studied.
So if the Ironic does provide you the way to first of all reset everything to the let's say factory one, and then configure it to the way you want it to, including which NICs to be used for PXE booting, RAID, BIOS settings, the whole 9 yards. Does that satisfy the requirement, or there is some additional thing which need to be done?
For example, if the ILO hasn't been set to PXE boot, how can you add it to Ironic? So you need some information before getting it to Ironic, and that information is not there. So the bootstrap has to be done manually yet.
Well, the driver itself have that, but Ironic does not have the top level command to expose it yet.
So I think the Arcady, I think what Umar is trying to explain here is it's kind of like you can't have Ironic manage it if you haven't done the initial bootstrap on the physical machine to set it up on DHCP or PXE boot. And if it has some arbitrary IP address on its BMC that is not reachable by Ironic. So
Yep.
I think what they mean
The
here is you
reachability-
have to go through that.
Yep. So there is a minimal requirement, which is reachability, and you have to have the credentials.
Yeah.
Ironic support two mode of operation. One is in band, one is out of band. For out of band, you don't need any PXE booting setup at all.
Correct.
And you can extract all of the data you want to, and you can configure it you want to, including the PXE booting itself. So, yeah. Yes, there is additional step need to be done in order to be able to set up the PXE booting, but you can, it's possible to do it out of band. So
well, I think what they're also trying to say is that the case that they're running into is there is no configured network or enabled networking for the BMC at present. So they're having to go through that step and or make those settings changes. And that really is going to require physical access right now.
So absolutely, this is why I put out the question. What is the minimal requirement, for the setup required in order to do something? Which is obviously if you don't have a network connectivity to the device on the server through which you can configure things, and there's not much you can do. But assuming that you have some connectivity to either ILO or iDRAC, or whatever is equivalent on other nodes type of the hardware, then that's possible, and including setting up the PXE and all of the other things. And there are support for assigning the IP addresses to those through the DHCP. So simplify things. I don't know if for different environment people might not want to hold dynamic IP address assignment, would like to have a static one. That's understandable. So trying to understand what is a bare minimal as a starting point was kind of the question for me.
Yeah, I agree with that. I think that's kind of that's the hardest part in all the operations, and that's mainly why we're here today. Is everything is nice and automated, but that's the only part that we need to minimize. And I think Omar raises kind of an interesting point. Of it's not always the case that you get hardware that's in a perfect world coming in with all the MAC addresses and all the information you need. I've seen stories that were shared with someone getting a shipment of a large number of servers that accidentally forgot to set up DHCP on all of those, and they all came with like the 192, 168, 1.120. So that required someone to go just in one by one and fix up all those servers, and obviously that is a very long and painful process. Also, I want to share my side a little bit on the question that was raised earlier on validating the hardware. So to us, it's been very interesting because of our focus on using open source software. A lot of the vendors, unfortunately, don't necessarily validate for Linux distributions that are free software, aka Debian. A lot of times there'll be like Ubuntu certifications and there'll be RHEL certifications, which indirectly gives you CentOS. And even those can be tricky sometimes because you got to trick their like little software validation tools that you're actually running CentOS, and it's okay to not like, don't blow up because it's saying CentOS and not Red Hat. But so that's been a struggle for us because a lot of times the vendors kind of just don't really have interest in doing that, and a lot of it falls on the community. And so there's a really strong, obviously, community to get on to help deal with these issues. But a lot of times what we end up doing is rolling out our own kernel and to get the newer drivers that fix some of the issues that are underlying in these machines, which is not ideal, but it's kind of part of what we have to do. And then the other thing is, like James also mentioned, is we work based on platforms. So, we start with one system and test out all the different use cases. And then once that's the case, we just keep reusing that same system for every single iteration of it. We have different flavors of the same systems. So once we have a specific platform and it's validated, some might have more memory, some might have less memory, depending on the use case that we're using it for. But overall, the things that need to interact together, where it's the networking cards and the drivers for those and the motherboard and all these different things, they all kind of stick the same, which makes it a lot easier to manage. Which now brings up another kind of interesting thing that we're discussing is environments with multiple flavors of hardware. So it's one thing to have multiple flavors that are running different memory and disk and requirements, but it's another problem to have a bunch of vendor A, vendor B, vendor C hardware. And how do you monitor all that? So I wanted to maybe jump back a tiny little bit and ask, how does everyone do things like monitoring? And what I mean by monitoring, I mean hardware platform monitoring. Like when, I think, Dell has their serve admin stuff, and HP has their own thing, and then Supermicro relies on IPMI. Do you set a lot of standard and stick to that standard for all your machines? Do you pick hardware specific things? I want to maybe open up and hear what everyone has to say from that. Well,
maybe I can start.
Sure.
For HP, and this is very preliminary. I don't know if that is standard practice or if this is even a good thing to do, or if there's better ways to do. But for HP, if you go to ILO, you get some health reports, and you can use the API to, I don't know, collect them or display them on a dashboard, for example. So if a disk is failing or some RAM slot is not accessible by the processor, you get that information. And then, for example, you can have a dashboard where all the servers that you are having are listed with their health status. So from the ILO, you can directly get this information using, I think, the Redfish API. They have different versions for different ILO 4, ILO 5, I think. And for Dell, I'm not sure because I haven't done it yet, but I think you can also get directly from the iDRAC. So that is the method that I know of, and I would be really interested to see how people do it for themselves.
Yeah.
Let me share some practice from Time Mobile. We use Hello. We use Redfish to do some management work or some monitor work, because now we in both for servers we all need the vendors support the Redfish interface. Use them to do some server management, assert management, and some monitoring and some alarm work. Now we use because we meet a problem is how to how about our enterprise requirements and the community, open community, the Redfish community version. So now I have some experience to share with you is that we we set up our requirements based on one Redfish version. But as you know, the community's Redfish version is increasing. It's hard for us to catch up. So our policy is that we will use one version, and if our enterprise have some customized requirements, we will add it into the specification. But at this time, we will first check the community's version. If they have this feature, we will add the feature into our requirements. If not, we will add some requirements as we need it. That's so we use this method to help us to keep to keep the same step with the community. At the same time, we also meet our requirements. Okay.
Cool. And so do you use Redfish as a standard way to interact with all of your systems at this point, or you still have a little bit more work before you can use Redfish everywhere?
No, because as you know, in the NFV cloud, we use Vim and PIM to manage all our hardwares. So now we for servers, we ask them to provide the Redfish interface. But for other devices, for example, some old devices, especially for some network devices, they still have some SNMP, such kind of interface. So maybe we will manage different devices according to different policy.
Okay. And I guess you have multiple monitoring systems, some monitoring that watches Redfish and other monitorings that watch SNMP or something like that?
Okay, but in fact, this is a big challenge or problem for our OSS systems to do some management and monitoring. But now gradually we will do some unified work to use a unified platform to do all of this work. We will try our best to do some standard work.
That's cool. That's a really interesting perspective to hear from your side. I'll share a little bit on what we do here, because we do have an interesting use case, because we actually manage hardware all over the world. And the other challenge is sometimes that hardware is not necessarily ours. So we don't actually always have a say in getting access to Redfish API or something like that. And the way that we've gone about this, so we actually run a Kubernetes control plane every single location that we run. And we built a tiny little tool called Node Labeler, which is an open source project. It's really interesting. It's a small Golang project. And it's crazy how even the small world is. I was looking for a library that extracted information out of the hardware and gave us, what is the manufacturer, what is the make, the serial number, and things like this, because it was really hard to manually add that information and label the nodes in Kubernetes. And I found a library, and the library was actually written by someone, Jay Pipes, who actually happens to be involved in the OpenStack community for years ago. So it was really interesting to have that circle around. But we wrote this little thing that we run as a daemon set across all of the nodes that we run. And what it does is automatically poll the system and check what is the make, model, serial number, all that information, and labels the node on that. And so what that allows us to do is it allows us to run certain Prometheus exporters on those machines, and we use the selector as the make and model of that specific machine. So for example, there's a Dell hardware exporter that allows you to get all the hardware information from a Dell machine, and that's just an open source project. And so for example, on all of the clouds that we run, we just run that hardware exporter as a daemon set, and we set it up as a node selector, so it only matches Dell hardware. So it only gets and retrieves stuff from Dell systems. And then we kind of do the same for like HP systems, and then anything else gets IPMI. So that's one interesting approach that we took. And that's mainly like trying to make the best out of all the different choices. I don't know if anyone has any questions or curious about how we do this. I can talk a little bit more in depth about it.
I'm really excited to know, is the Dell Prometheus exporter an open source thing that you can run anywhere, or does it come with some support package or something?
Yeah, so it's an open source project. I'm not the one behind it. I just happen to be one of the users. I'm going to post it in the Etherpad here. Grab it. I just Googled it up. So going to be on line 139 is the hardware exporter. And so we run that. We run the Docker image that's shipped there. And then if you also want to have a look for the node labeler that we run, I mean, you could probably, well, it's really meant for running inside Kubernetes, but if that is something that interests you, it's also set up here. So you can do that. And I think we have a Helm chart for that somewhere. So that's something that could be interesting if you're using Kubernetes for bare metal and whatnot. Cool. I guess we're mostly halfway through the discussion. I wanted to touch on one last subject before maybe switching it to the BIOS and firmware automation. And I guess the question is going from one data center to N data centers. And I'm wondering if anyone kind of would like to share their experiences, because I think whenever you start building out your first rack and you grow into a second rack and you're growing more, you're not really thinking about way down the line, and this is on line 145, you're not thinking on way down the line when you're going to have two data centers. And then all of a sudden, you've got to decide what your network segments are going to look like, and are you going to have how your VLANs are going to look like, and are you going to interconnect those data centers, and what do you do about all that? So has anyone maybe recently gone through something like this that they'd like to maybe share a little bit about their experience in going from one to multiple, or how do you deal with multiple data centers? I know I saw unmuted from China Mobile. I'd love to hear how you're doing, because I know it's at a very large scale, that's for sure. Okay, I don't think we can hear you. Yeah, it's cutting off a lot. I just heard a blip of noise. Fortunately, technology isn't perfect. And that's why we're here.
So Prakash here, I can chime in a bit.
Yeah, sure.
So the biggest problem one faces is if you design one data center and then suddenly you did not plan for the second data center and it comes up, first thing comes to mind is, oh, should I, example in OpenStack, do I have a federated or do
I wonder if we lost Prakash.
Yeah, I was worried that it was my internet that's acting up, but
yeah. I can.
Internet.
Oh.
Go ahead.
So,
Are you able to hear me?
yes, we can.
Yes, we can hear you again now.
So the second challenge comes is once you have a mix-up between the Kubernetes being part of it, and so you have container workloads as well as bare metal and VM workloads. So the challenge comes to which one do I use? Do I use the Keystone as the main provider and have external authentication, or do I look at go to Keystone and modify all those external versus federated, and then there is a conflict or something? So not only that, this is only on the authentication triplet side of it. The other side of it, if I am asked that, hey, I need to have a OpenEDX installed for educational segment because we have got hundreds of data centers. Now what do I do? So the API of the application, the authentication are the key associated with that. So that is one part of it. The other part of it is from the networking side. I'm forced to decide how do I do networking. Is it provider networking, or am I just going to use a router and do a BGP and externalize? So many thoughts and multi-site, we need to think top down, whereas you are stuck in a data center which you designed without thinking that. That's the major challenge we face. So it is networking issue, it's authentication issue, it's a capacity issue, and also you don't know what providers are available to you. Example, if you have to go through a telecom provider, who are available in that area versus who are available in other area? How are they going to allow you to have the either MPLS, or are you going to go through the BGP? How do you get that, and what kind of switches you have ability on either end of it, which was not pre-thought. So that's why you go with a reference design, a standard reference design, which allows you for best practices that are done in both ends, for not just two, you can have multiple, right? It's not like we are only talking of data center 2, it could be multiple. So therefore, always it is preferable to start with the data center. If you have the, what you call the luxury to start fresh, always make sure go with a reference design.
Yeah.
So I have an experience so far in the past where we built one data center, we ran out of space. We built a second data center in the same building. We very promptly ran out of space within, I think it was 13 months. So we ended up building yet a third larger data center not far away. But when we started building that facility, we had to look at everything from power to our risk profiles to what actually are, as Prakash mentioned, the carriers that were available to get the fiber there. We ended up doing our own fiber in the ground for part of the area just because we had to make it work, to have the bandwidth for our systems. But we ended up having to build this entire profile of all the risks, all the things that we needed. And we had to very methodically work through that list. And even to the point where we were walking around the streets nearby to try to find the carriers that wouldn't talk to us directly, so we could find out who owns fiber, so we could figure out where to bring in a secondary network connection. And it's all those things you don't think about until you actually you're on the ground going, oh, I need to figure this one out now too.
Yeah.
That reminds me of one thing. Some 10 years back, I had a data center to migrate in Palo Alto for one of the commercial players. And the problem was they moved from one place to another. The other place, you don't get provisioning. You go to AT&T, apply for it, takes 6 to 8 weeks to get all the stuff. And the lease is running out. So what do I do? So what I had to do was take a wireless provider to over the air and connect it to the data center to enable it for running bare minimum so that they can operate it. And it was one of the biggest challenges I faced. I have run data centers several places, including my own in 90s, starting from zero. It was called something called, what was it? Internet. So it was from at that time it was Netcom and other players, so it was easy to get some IPs and here. And when you go to next place, you don't know what IP subnet you are going to get, because if the provider has not provided you, then you are left with only what is available. So IPv6, the ability to route, and then you have to borrow from some neighbor who has got it to run the data center. So situations are very, very dynamic. One cannot predict what you will face when you, especially have a situation where you have got one data center you didn't plan earlier for the second, or any of these migration issues also.
Mhm. That's really interesting. Well, yeah, running over wireless feeds must be really interesting to do that. But I mean, we can't sit here and all admit that we haven't all thought about, doing some really questionable thing to get us through a very specific period of time. And, we all have these stories of having to kind of work around an issue using something that's very not unusual, I would say. The one kind of small, easier topic that I'd like to touch on, and this one is common in every single operation, which is tracking component changes. So it's all nice and dandy when you come in and you have all the MAC addresses and all the perfect serial numbers for everything. And then with times, drives fail, NICs fail, all different things fail and change in the system, and then your initial state is not the state that the server is today. And a lot of times, even sometimes, it's just going to be part of an operational thing where, somebody decided that we're going to upgrade the memory on all these boxes to something else, and all of a sudden that's all changed. And so my question is to kind of everyone's sort of conversation is, how do you deal with these changes in an environment, and how do you track those changes? Do you have a long living asset ID? Do you kind of recycle the asset, as in like it's a brand new asset with a new set of systems that are set up? How do you go about doing that?
I mean, that seems like a number of different questions. I know that at least from a community standpoint with software, there's been some interest out there of being able to re-introspect. We actually add support so that someone could re-introspect a machine that's already been deployed, which I hope someone finds useful. But
I can confirm it's very useful. Use it a lot, actually.
Excellent, that's great news. For this use case?
Roughly speaking, actually, it's often when you reconfigure the RAID and you want the boot hint to be fixed. It's easier just to reinspect it and it gets it right again. But yes, also NIC swaps, same thing.
Yeah. Okay, that's interesting. And then, so John, you're kind of mentioning so the introspection. So assuming, are you relying on like Redfish or like the hardware specific out of band introspection?
It's a good question. So I meant to share what we were doing earlier and we moved on, but so I mean, the simple thing is for us, because we work with so many different people, we see a huge spectrum. So a lot of people, we might get a spreadsheet where it says, these are the IPMI addresses you're allowed to touch. Good luck to you. Some customers we work with, and actually that's quite good because usually they fixed it for everything for us, win. Some customers are, okay, so we have to install the Linux for you. So what did you want? But more recently, we've been working with Cambridge on the ground up, and they do a very similar process to what you're saying. We're scanning MAC addresses. They do handheld scanners for MAC addresses. Actually, one of the things I was curious about, which I'll just put on the backlog as a question, is how do you care about finding the broken machine? But let's pause that for a second. But what we tend to do with introspection, or what we tend to do is once you've got it enrolled in Ironic, we just do introspection to use LLDP information to find out where it is, because we don't trust the cabling information. And that LLDP seems useful because that's the way, although we're jumping topics, that's generally we're often using like networking generic switch or something like that to configure the switches. So we need to know the switch MAC and the pork address for Ironic to do the right thing. And LDP seems the most sane way to get that information. But yeah, we tend to use a lot of introspection. So for the Cambridge case, what we're actually doing is doing iDRAC DHCP based on the MAC addresses from the handheld scanners. So that gives you the host names. All that information, you then just enroll the node in Ironic. And these are actually all Dell servers. So we're using the iDRAC out of band information to get the MAC address for the 1 gig Pixie. So then we can reconfigure the BIOS to do what we need. It wasn't quite, we did request something, but it wasn't quite right. More because we requested the wrong thing, I think. Anyway, so we just reconfigure the BIOS to do the right thing on that 1 gig Pixie NIC. The important thing was the iDRAC came doing DHCP. That's the only thing I really cared about, because that meant we got the IP, which is going back to the previous conversations. But so we actually did out of band inspection to get the first bit of information. Then we did in band inspection to get the rest of the information. Because we just got an awful lot more information from the in band inspection. So to answer your question, kind of both. But that was kind of just the journey. In this particular case, we were using like Mellanox ConnectX-6 NICs that didn't come with Ethernet enabled by default. So we had to do everything on the 1 gig to move on to the high-speed network. But it was a bit of a journey. But yeah, I think both have proved interesting in their own right. I kind of like how the out-of-band means that kind of you don't need to be able to Pixie boot to get the information. But on the other hand, in-band is great because you can kind of run arbitrary code inside your inspection image to collect whatever you need to collect. So yeah, I think it's been quite a useful tool all over the place.
Well, I was also kind of trying to point out that we added the ability for, if you have it running OS on a machine, you can say, you can install the command and actually directly go, I need to supply update information to inspection right now.
Oh, okay. Oh, I was thinking about reinspect via the API. Okay.
Oh, no, well, there's that too, but.
That's what I was thinking. Okay.
Cool. The idea was, oh, I've had to recable half the server because the requirements changed or whatever. These things do happen in physical data centers. And I need to update that networking information, or I added hard disks, or I removed hard disks. And while it is a running instance, I've made a fundamental change to the machine, and I need to somehow supply that information and not really interrupt the running workload. It's not exactly a cloudy thing, but it's still a case that you still have to support when you have bare metal machines out there.
No, that's interesting. Actually, yeah, that's going to be much more interesting on hypervisors, actually, thinking about that. I think generally I quite like using introspection as in via the API as a way of just resetting the state of the box, because you go back to manageable, do inspection, and kind of recycle the box as if it was coming in fresh. But yeah, that's a different case.
Yeah, the nice thing about like doing like introspection on an active instance where the user is on and using it for something, it's like you can like track any changes that Julia said. So for instance, if something is replaced, and you would afterwards, like a couple of months later, you want to know which firmware version is running on which hosts. If you have to like replace the firmware version and you have up-to-date information, this active introspection introspection active nodes is actually quite an interesting thing to have.
So
I think I'd always assumed that you would deprovision the machine before doing that kind of thing. But yeah, it's good to know.
Yeah, I could see that our users would even want to do stuff like with an active node, they would actually want to have it basically go through and if possible, run through some automated process to update firmware for them in some cases without deleting their instance.
Exactly, that's the point. I mean, if we would ask like all our users, okay, we have to update the firmware, you have to delete all your instances, give the nodes back to us, we update the firmware, and then you get your nodes back, that wouldn't go down very well.
It's exactly the same for us. Our users are addicted to their running instances. They can't give them up.
Well, which also brings.
So you've been using. Sorry, go ahead, Arnie.
This also brings up the other issue, of course. If you say like, if you hand out, at least in our case, if you hand out a physical node to a user, the user thinks that he owns the machine, right? If you have like active introspection, you need to have something on the user's instance that's actually actively monitoring it inside. So you can probably only do this if you have some kind of policy where you say like, look, you can have an instance, but you only run with these images, or you have to install this container in order to like keep us up to date of what's going on the machine.
Yeah,
we haven't
exactly.
tried this yet to like push this out on many users, but we had this before, where we basically, so when our machines were installed or are installed with Puppet, we have some kind of base modules that also include some sensors that would collect this data and just send it into our CMDB or DCIM system.
Yeah.
I'm curious, so when you get users to update, oh, sorry, go ahead.
No, go ahead, John.
I was going to say, like, when you get users to update the firmware in place, are you providing like, please run this script on this OS to do this thing?
No, it's not like we ask the user to update the firmware. The example I had was more to like understand, for instance, if you have I don't know, a delivery that's like 2 years old, and then all of a sudden there's an issue with the hard drive firmware, and meanwhile you have replaced disks left and right, and you don't know which firmware level is where, and you can then identify, okay, I have to like attack only these subset of machines rather than all of them, because I know that like on so and so many the disks have been replaced meanwhile. But we don't ask our users to update firmware.
That's yeah, that would be really handy, because one of the things we've actually done is because even a lot of our users can't even stand to kind of reboot the hardware. So I still want us to get that active reinspection, because I think that would be hugely useful for us. What also I think but what we also still have to do, because of users that don't even want to reboot, for us to find out what firmware they're running, we work with our security team who has some scanning tools that run on our production servers. And that's just part of the data center policy, right? If you run the data center, then our security team needs to have access to at least run this sort of scanning infrastructure that uses signed, the sort of GPG signed pre-authorized commands that it'll SSH in and run that. And so we've worked with them to do things like scan all the machines in the company and find out which ones have this known bad firmware, for example, that don't work with certain versions of RHEL. And then that way we're able to target those machines, mark them as being in maintenance mode, reach out to the properties that are consuming them, and let them know, like, hey, if you try and reimage this to like this newer version of RHEL, by the way, it's not going to work.
Right.
And you don't all trust the out-of-band information, I guess, because there's too many out-of-band types to talk to, or?
That one we had to do entirely in band. That we actually literally had to literally SSH in and just run some inspection commands.
Okay, so it just wasn't possible out of band in that case.
Oh yeah.
Is this something where something like OS Query, if anyone's familiar with that, could kind of be interesting for something like this?
We used OS Query for a while and then we stopped. I think there were some performance problems with it because it would gather this huge pile of data, then ship it off. And we definitely were using it for a while, because I used it for a project like this in the past where I used like all the OS Query information from the company was shipped off into Hive. And then I used Hive to do some queries to extract some data from it. But we had to stop using it because of all the performance problems it was causing. And by that, I mean, by and large, most of our application owners they're not using, if they're using bare metal, they're really not using the machine to its full potential. Like we have a lot of idle CPU cycles, but some other properties at the far end of the coin where they like push the machine to like 99% of what it can do. And even our configuration management system running slightly too often was actually causing their QPS to drop. So it was like an interesting two ends of the spectrum there. So I think that was one of the reasons why we actually stopped using OS Query.
Mm-hmm.
I mean, the beauty of using like or redoing introspection while the instance is live is that you collect the exact same data in the exact same format, and you can send it to the exact same backend. right? So rather than having something like when the node comes in, when the new servers come in the very beginning, you collect one set of data. I don't know, how many CPUs do we have? What is the firmware version of the disk and so on? And then later on, you do something else. You have actually the same code doing the same things, and you just update your DCIM.
Yeah. And so just, we're talking a lot about very maybe ironic specific terms, and I wanted to call out if there's any other users of different bare metal orchestration platforms like MOS or I think Digital Rebar, or there's Tinkerbell. Anyone's kind of using those and can maybe talk a little bit about the idea of kind of having an updated information or profile about the systems as they're running.
Hey,
So
this is Rob Hirschfeld. I can talk to Rebar if you want.
Go ahead.
Sure, and then we can have Rain share some stuff after. Cool.
Sure. I'll give you camera too. Hey, so this is Rob Hirschfeld. Y'all, I've been in the community for a while, but not active lately. And so we've been doing Digital Rebar for a long time, and it as a primary workflow will start within memory. So our primary is not reliant on out of band. It relies on a Pixie in-memory agent model. And so we have developed what's gotten to be a very comprehensive hardware inventory scan process. It's not invasive, and so we will run that as part of any boot process workflow. And that'll collect pretty much as much information as we can possibly get. LLDP we did as a secondary thing because that's not always turned on, so it's an additional workflow step. And it takes time. The overhead of collecting the data is pretty small, but then that gets stored back automatically in the data set. And then we have additional downstream workflows that it's a huge JSON blob. It's actually probably the biggest single piece of data in the system. So we flatten it. So we have a secondary system that'll then scrub that into smaller, it flattens it. And then the nice thing about flattening it is that then you can search individual items that you want out of that item for secondary consumption. So if you then want to search by manufacturer, number NICs, RAM, whatever, you can't, it's hard to search into a JSON blob, but you can then add those as searchable items. And then one of the things that we added once we had that data was then you can, it tracks the last version of that and it will do comparisons. And so if you want, it'll warn you that there's issues, it'll stop if there's issues. Boy, and then we collect there are all sorts of other information collects on the machines in an ad hoc way. So any information that you wanted to collect, we include, and then you can make those either downstream, force them into downstream systems, feed them to a data collection CMDB type system. You can feed them into other inputs and profiles. So like we have Ansible scripts that you can kick off, and then we'll insert the relevant data from the inventory into the Ansible scripts, either running on the machine or from the server. Same thing with Terraform from that perspective. And then, but we have as a process, while we do out-of-band management for all the different vendors, using whatever vendor out-of-band management stuff, we don't rely on out-of-band management. So we can do things like boot a Raspberry Pi. And we found that to be really useful. While it's useful to have out-of-band management, there were some other use cases where that didn't work so well. Well, like it wasn't set on first boot or something like that, which is very common.
Mm-hmm. Well,
that's it's hard to condense all that stuff into a single thing. So I'd be open to questions.
I think there was a question from Arcady asking if boot image, there's a required boot image support for embed introspection.
For what type of machine?
I'm not sure, Arcady, you want to chime in?
I see it.
Yeah, it's for generically when you try to introspect the hardware, if you do it in band or out of band, and it does require the boot image support ahead of time?
That's a good question. No, none of the agent work we do is image specific. So the way, since we use Golang as the image source, it's multi-arch and multi-OS. So we have the exact same tasks running on any OS for the system. So when we do discovery, it's the exact same code, which is really handy. So if you want to do work, you build a workflow that works in the discovery image, which is based on CentOS. It'll work just fine in any Linux. And most of the stuff is cross OS, so it'll work on Windows also. ESX is its own weird beast, but ESX or RPi or Mac. Not that many people are automating Macs.
Mm-hmm.
We do for a test, but not much more than that. And then we can, there's a feature that we added that allows you to move the agent out of the machine and back to the server. And then so you can run, if you have an out-of-band task, or if you have to connect to say a switch or another external system, you can transfer the agent dynamically into a container running on the endpoint, which is the server. Server gets really overloaded. And that would then let you do, if you needed to do something esoteric from an out-of-band management perspective, you could move the agent to the server, pull in whatever data you needed from the system, and then take those actions against it. We've been doing that more and more. We have a whole bunch of server-side control points for out-of-band management. And some of them, like when the machines are not on, changing boot order, which is really important, as y'all know. We used to do that as a sort of a dedicated process, but once we did the context switch to the server, it became easier to just run. Basically, the agent is always alive, even if the server's off.
Yeah, cool. As we're kind of getting closer on time, I would love to hear some comments from Rain, because I think there's a different perspective where you can't run much in the system, unlike some other examples where you can run something in the system, and that's kind of in the case, I guess, of Tinkerbell, because it comes out of Packet, and that's more of a provider-based thing. So love to hear about that.
Right. So Packet was founded 5 years or so ago. I will caveat this with, hey, I'm Rain, and I was with OpenStack for a while, for 5 years or so. But I played a lot more with OO and Packstack and RDO, and not so much with Ironic, sadly, even though Julia and I would hang out a lot. So I'm very new to this bare metal stuff. I've never done ops or sysadmin work or anything like that. But one of the reasons that Packet is excited about me is for the DevRel side and for my open source experience. And that's what they've recently done, is taken a piece of the functionality that they use to provision their hardware, which instead of renting out virtual systems, you can rent out straight bare metal, and you get a dedicated machine and whatnot, and it's super fast, So they're starting to take pieces of that functionality and make them open source. And the first one that they made open source is Tinkerbell. It's a baby open source project. Mara is online with me today, and she's going to correct me if I'm wrong with anything, but basically it's bare metal automation. So it detects the system and then spins it up for you, and you can use it for monitoring, but that's not its real primary purpose. Its aim is to give you the system with whatever operating system you want ASAP. It's 5 minutes to dopamine, 10 minutes to dopamine, something like that. So yeah, I'm listening to all these questions and I'm absolutely fascinated by the different experiences, because over here, we're trying to provide that hardware as if it were software. So at that speed. And honestly, the ops people are the magicians for me. I'm just fascinated by all these decisions. I do know it's fully automated. I just don't know how, which I guess is the dream for automation. You want to be able to have someone click and it just magically appears.
Yeah.
Definitely agree with that.
Yeah, that's what that's why we're here. We're
Yep.
trying to get the parts that haven't clicked yet.
Correct. But
Yeah.
I want to point out there is two different angles to look at that. So one angle is the tool set needed for that. But the question is, how is that delivered? Is it delivered as kind of self-type service, as a service, or as more kind of a product or integrated into the thing? Because if you are going to the service, then you have to worry about all sorts of other stuff, the security, identity management, and all of the other 90 to ensure
storage.
to ensure that you have all the right access to the right things, versus if it's part of the kind of integrated administrative domain, then it's a much lighter. It's a very different delivery vehicle.
Yeah, it's more towards the latter, because we want to stay away from, we want to specialize in hardware delivery. So we've specifically stayed away from, for example, storage. We've stayed away from networking. We're trying to stay and specialize on layer 0. Mara might have more input on this than I do. Or not.
Yeah, unfortunately, I think we're getting close to our time. I think our break is in 1 minute exactly. So I want to thank everyone for actually participating in this conversation. It was really nice and really helpful. We got to hear a lot of different stories from a lot of different scale. I want to individually thank all the folks that participated for this first half. To kind of end it on a very bad joke that maybe some people will get the reference. But someone asked us, how do you, I think it was John asked, how do you find the machine? And that reminds me of like a very old IRC quote that was like QDB, which is like, I've lost a machine literally. It responds to ping, it works completely. I just can't figure out where in my apartment it is. And I do feel like sometimes maybe we deal with that in our systems. But yeah, thanks everyone. We're gonna go on a short 10-minute break and then we're gonna go back for the next half. That's gonna be moderated by James.
Thanks, Al. See you in a few minutes.
Okay, see you.
Thanks, Mohammed. Yeah, so we will take a short break. We will see everybody back here for the next part of our hardware provisioning lifecycle for bare metal discussion, part 2, in about 10 minutes. So see you all then.
Thanks, Ashley.
I like the whole music. Thank you.
All right, welcome back, everyone. I'm feeling very calm and chill after the musical selections there from Aaron Disney. So we have one more section for today, and we will be moderated in this section by James Pinnock. So he's going to continue the discussion on the hardware provisioning lifecycle, and I will pass it over to James to take it away.
Good morning, everyone. All right, yeah, so let's kick this off. In fact, where we left off in the first session, I think is a great place to pick this up here. We had started to talk about firmware a little bit. So to start with, one of the things I just kind of want to throw out there is how many of you are sort of like 100% or mostly on UEFI versus how many folks, I'm curious, are still using BIOS? This is something we're still doing just because for us, it's a lesser common denominator thing. And I wondered if anyone else want to talk about, like, are you using UEFI and some of the more advanced features of UEFI right now?
I think on our side, the answer is it depends. And sometimes the hardware can be very finicky for UEFI and depending on the OS you're installing. But most of the time we try to go for UEFI mainly because just generally you get faster boot times and just kind of the idea of future-proofing the infrastructure. I don't know that we're taking advantage of anything like any fancy UEFI features that we can take advantage of, which we don't.
Okay. Yeah, and so that's actually good to know. It hadn't occurred to me that there could be like some finicitude with UEFI. And Kurt, on the Zoom chat, I see that you're actually using both, predominantly BIOS, and I was wondering if you'd be able to share a little bit about kind of why you use one versus the other, or any experience you've had.
Well, I still have gear that is ancient that I'm trying to leverage that just works on BIOS, and I've run into some issues with the UEFI boot in older versions of CentOS where it would just on an upgrade to like 7.5 to 7.6, the UEFI went sideways. I do have instances where I have some cards that demand that I boot with UEFI, at least to do the initial configuration. And I have run into the same kind of issues where some hardware is finicky when I do boot UEFI and some hardware is finicky when I don't. So it really depends upon the piece of gear or set of servers that I'm deploying at the moment.
Okay, that's good to know. Sorry, go ahead.
I've seen a lot of people still trying to use BIOS, and a lot of the cases where people are forced into UEFI, it's because their hardware needs it or they need the memory access for the hardware to be able to have the greatest performance possible, or some of these more edge cases that you don't normally think about with hardware, but they are things that you have to consider.
Yeah, that's a good point. And then for those of you that are still using BIOS like us, I noticed that some of our vendors, I think, are actually starting to either do or talking about actually charging an extra fee per machine to support BIOS as well. So there's certainly an impetus for us to want to get off of BIOS, not just for future-proofing and technology advantages, but also just to be able to just to save that extra surcharge on hardware. Oh, Ava has a great question. If anyone's using UEFI to support secure boot and related things, so that's actually, in fact, one of the things that's coming up here. So we can even skip ahead to that if that's something that anyone's interested. Does anyone use UEFI to support secure boot? Some options of it, including this would also be like measured boot or even using signed images.
I think that was something that we were looking at, but I think one of the struggles with this, and could be just a general infrastructure struggle, is like when you want to implement these new things that some of the subset of your new hardware supports it, but you have like an older subset that still has no support for it and kind of makes it a little difficult to implement it. And it feels like you're half doing it.
Yeah, We're starting to do in some cases in parts of our infrastructure, we're actually using signed kernels. Not on our OpenStack managed pieces right now. We're actually doing it in our secure edge sites, which are not currently OpenStack managed, just because we have some features we need to add before we get there. But in those environments, we are doing signed images, and in those cases, the signature is actually put into the public key. I think is actually put into the TPM on those hosts. And then the kernel has to match that signature. We want to make that the default for everything, and so part of that is us adding the UEFI support to our on-premises ironic, not our edge sites, but our on-premises ironic stuff right now. And then we want to actually do that by default for all the bare metal stuff. There's some tricks to that because that causes some problems when it comes to allowing, if we ever want to allow our application owners to use snapshot images to deploy their instances, at least on bare metal. We certainly encourage that for VMs, but for bare metal, we don't currently support that. And once there's an image signing element there, that's going to complicate that a bit. That's something we do want, though. So I'd really like to know if anyone sort of addressed this in any way, if you've built any automation into how you provide base images to folks.
Just a question. So when you're using these signed images, are you signing them yourself, or are you using like the signed ones that are kind of pre-signed from dollar sign vendor?
We're actually signing them all ourselves. So we build our own base images. We we take the kernel, we build our own base images, and then for the ones that are deployed in signed locations, that we then sign the kernel as part of building the image.
We don't have that challenge because we kind of rely on the vendor signed images. So
okay, that makes that easier.
Yeah.
I think most people.
Go ahead.
I think most people, at least those I've talked to, tend to use the vendor supplied images. They tend not to be doing their own PKI and certificate signing inside their infrastructure for secure boot.
Right. Which is actually an interesting question then, for folks doing their own I guess before I skip ahead too quick, so it sounds like most people are actually using the vendor signed images. Is there anyone else out there like my team or my company that is signing their own?
I have a question for you along that. Does that mean you're also updating your TPM to include your own keys?
Yeah.
Okay.
Yeah, but I should say it's currently only happening on the machines that are going into those edge sites where we're actually using the signed images. We want to do this for everything. And so part of that is actually how do we start to sign images for all machines? And so this is actually going to change how we do our hardware intake process a little bit to, how do we automate this? Do we have like a clean room section of the data center where machines can go in and then they can be, and then the trusted keys get put onto the TPM there? That's, I think, one of the things we still have to work out.
No, it's reasonable. That interacting with the TPM is going to require, I'm assuming you have to do that from a trusted place anyway, but
yeah.
Yeah, I'd be interested to see the process you're using for doing that, because I think being able to add keys into the TPM as a standard process would open up the use of TPM much more broadly.
Yeah. Yeah, so that's going to be the thing for us, because right now, since we're only doing this for hardware that goes into our secure edge sites, it's low enough that it's basically just a human with a thumb drive. If necessary, they can go and they can put the correct thing on. But doing this scalably is something we kind of need to start thinking about now, so that we can work with our site ops people to sort of figure out like what should the process be, what's the chain of trust for hardware coming into the data center. And receiving the image, receiving the key, the TPM.
Yeah, I don't want to pulse off, but if you want to contact me offline, I'm happy to talk about it more.
Absolutely.
We have processes, and we've talked to people about stuff like that.
Actually, there's a bullet here specifically on that. So I'll touch on some of these other points. And then I think I actually really want to come to exactly that point. Actually, let's talk about that right now. Could you share what the process you use for securing or for programming your TPMs is?
We don't. So I don't have a process for. If I had one, I'd wrap it and we'd include it in a workflow and just make it part of standard process. So that's the okay. Question to me that's going down the rabbit hole. I'm happy to talk about it. I just don't know if it's vendor specific or what the tools are. I have 5 or 6 different places we can poke stuff in. Mm-hmm. And I just need, I don't have the operational infrastructure to play with it outside of it.
Oh, right.
What I do know is that and part of the challenge with the TPM and the secure boot pieces is that it's not 100% thing most places. So you have to be able to detect whether the system's in secure mode or not. Serve up. We actually serve up different IPMI at different boot stages depending on secure or not secure, and even a secure system might boot back into non-secure modes to perform certain operations. And so you actually have to be able to bounce back and forth from that perspective.
Right. That's fair.
I'm wondering, oh, sorry.
Go ahead.
I'm wondering if anyone from Keyline has joined us today, because they have a bit of code that allows taking ownership of the TPM and doing key injection into the TPM, and then basically doing attestation of the machine.
Yeah, so this would be sort of like the signed measured boot then.
Basically, yes. Yeah. You'd end up asserting the key, establishing the relationship, and then there's a whole nother step and process beyond that.
Yeah, I can actually share something on that to start. This is again in our secure edge sites. We are actually doing measured boot. So where certain values on the machine have to be consistent, including like certain firmware versions have to do a certain thing. The certain values in the BIOS have to be set a certain way. In addition to, so all of those things have to be true to unlock the TPM, which then contains the certificate to validate the kernel. I'll look and see if the team that designed and built that infrastructure, I'll see if they released a white paper, because I know they released one internally and I thought it was really interesting. So I'll see if they've got something they can share publicly, and if so, I'll come back later and add it to the Etherpad.
That'd be awesome. Thank you.
Yeah.
That's a fascinating use case. And I was asking my team in the background, and they haven't seen any customers using the measured boot, but that's super interesting. We did have an attestation process where we would go with our in-memory discovery image, collect a signature for the drives, and then since we boot back into that, when the systems come back up, we can make sure that the systems haven't changed, that the drives haven't changed from a signature perspective without actually booting to the drives. Mm-hmm. So we worked out that as an attestation process, and then you can encrypt the drives and then require a LUX key to complete the boot.
Okay.
But different. I mean, in some ways, that to us was more secure than a TPM, which just makes sure that the OS hasn't been tampered with, and that you're getting the OS image you think, rather than that the system itself can't be activated until after a LUX key has been provided.
Right. Yeah, that makes sense. Something that this conversation brings up, and Ava said this here in chat, that they would like to see some SOPs documented in open source for adding and managing keys in TPM. They'd be happy to add to that, and then also there's going to be some architecture specific pieces. I actually really like that idea. I think that would be really useful. I'd like to definitely be a part of a working group that would own that and just produce it. Maybe we can author a paper together or something, or put something on the OpenStack website or wiki even that just says like, here's a list of good standard operating procedures just to help other operators and deployers get started. So if you're interested, if someone wants to put a line on the Etherpad, we can just put our names and email addresses there, and then let's all circle up and we can talk about that. I think that would be really useful. So one of the next things I want to talk about is, you know, and this I think is really helpful because I think something that just came up is really ties into this is reasserting hardware being safe for reuse. So, and this is particularly important, I think, for those of you that are running bare metal in sort of more of a public cloud kind of way, or you're using physical hosts to host other people's applications. What are things that you're doing to assert that the hardware is safe for reuse from one tenant to the next? Are you wiping drives? Are you doing firmware inspection?
Well, I think one of the things that's kind of hard is, you know, it's like, how do you make sure you close all of the different things and you don't miss one tiny thing, right? It's not a virtual machine where everything disappears. And so for us, at least on our side, we've been using some of the ironic cleaning steps. And, you know, it's maybe not as efficient because some of them just like take very long time, but a very long time is a lot better than any security issues. But unfortunately, I think the hard part is remains like the firmwares and things like that. And that's something that's very hard to change and modify because, you know, a lot of these cleaning steps I think don't actually include flashing firmwares, and you would really need the system that supports out-of-band firmware flashing to do something like that. So it's definitely a really hard problem to solve, and it's one of those things where you can make a lot of progress, but it's hard to fully lock it down and be like on a super clean slate on that.
It is, and it seems like the problem that at least I seem to encounter in the open source community with asserting firmware flashing is maintaining that possible matrix of device to firmware image, the version that needs to be on the machine to the version that should never be on that machine, and how to manage all that and represent that into something that can programmatically execute and run. And also hopefully not brick machines. Like it's kind of funny to think about, but we actually lost a third-party CI last year because someone went and upgraded firmware and bricked the machines. And it wasn't ironic that did it, but it was someone that plugged a thumb drive into the machines in the data center, and they just didn't raise a ticket at that point.
Yeah, so this is interesting because this definitely is part of the life cycle stuff that's really interesting to me. You know, this element of how do you build a matrix of supported firmware, and so we have sort of a high level working agreement with our internal performance engineering team of like how we probably should be doing this, but we're not right now. Does anyone operate in a single or multi-vendor environment where you're doing automated firmware updates in any way?
I know Rackspace was with On Metal. They actually had an entire hardware manager that would do all of this for them, but it was in band and it was explicitly tested to operate on those machines, and they only had like so many variations in their data center as opposed to what you end up with most data centers where it's orders of magnitude more variation.
That's a good point. Yeah. And Rob, you said this is actually something you're doing right now.
It's a core thing that, I mean, it's our expectation is heterogeneous. Yeah, I'm happy to talk about what's the I think this is, it's subtly more complex because even inside of even if you're single vendor, changes within the vendor's management tooling will cause drift that effectively makes the systems heterogeneous. And so we see this all the time where even one version of firmware, like a firmware patch comes in and a value of the firmware changes, or the behavior of the firmware patch process changes. And so we're constantly playing whack-a-mole on challenges like this across the board.
Interesting. So this is cases where, like, for example, for upgrading like IPMI firmware, normally the process is like you upgrade IPMI firmware and then reboot and then upgrade BIOS, or vice versa. But there's like a chain, there's an order of operations in which firmwares you upgrade in which order, and not just that, but also the tooling and manner in which you upgrade a piece of firmware. Plus also, like we experienced something recently where we upgraded firmware and it actually changed some other BIOS settings on the host. And it actually, just upgrading the NIC firmware, I believe, caused the boot device order to get reset back to hard drive first. So it didn't PXE boot.
Pretty common, yeah.
Yeah. So those are things that you've dealt with. And it's interesting is that I don't think that there's any central place out in the world where any of this is being captured, because I think that would probably be really useful for all the different all the different consumers of hardware.
Yeah, I mean, we capture it from an automation perspective as we keep, you know, having to add, this check and that check and things like that. We don't, like, we call them quirks, but we don't sort of publish a quirks. Never even quite thought of like all the quirks. It'd be useful because it's tribal knowledge at the end of the day. But it's bizarre stuff. It's things like different firmware. They change the way that the password difficulties requirements are enforced, and it's all over the map. So we end up having to be very resilient from make this change, check this change. Usually we use the vendor tools. Actually, always we use the vendor tools to do that. So we come back to talking to the vendors about, hey, we tried this and it didn't work, or we tried this and it has a 20% failure rate. And that's the other side to this. It's not just that it's heterogeneous. There's also a significant failure rate in some of these firmware operations where they don't take the first time. And so you have to assess and validate and then repeat.
I seem to remember that at least one vendor out there does have some out-of-band tooling, so you can do out-of-band firmware assertion. But even then, I think it's, again, one of those things where sometimes it may not work, or it ends up booting the secondary ROM of how restarting power, and all of a sudden you're going, why didn't this work?
We spent a lot of time dealing with out-of-band. It can be not as reliable or very time sensitive, so that we rely very heavily on the in-band processes, in part because they're very transparent for us. So if something's going wrong, we can usually see it because we have a live OS to play with. I mean, you can see stuff happening out of band also, but it just becomes a little bit more of a, figuring out what's going on and what it's talking to and all those things.
Yeah, it's a bit more opaque when you don't actually have full insight as a consumer of the hardware.
Mm-hmm. Yeah, that's opaqueness is generally always harder.
Yeah.
So I guess, the heterogeneity is real. And actually UFI and we were talking about UFI and BIOS modes, those actually can have different tools, or some of the tools only work in BIOS modes. Still, some of them only work in UFI mode. So it sort of is there's some hard things to deal with.
Right. Yeah. So
there's also the fact some hardware have completely different firmware images depending on UFI or BIOS mode.
Yeah. And
one doesn't update the other.
Yeah. So I think one of the good points that came up here, right, is that even if you're in like a mono vendor environment, is that you still end up having these different permutations such that, like to Rob's point, it still ends up being kind of a heterogeneous environment. So I think that something that would be interesting in the long term is if there was a way to figure out, like, is there a way to have different deployers come together and at least collaborate on like a list of, this is actually another great opportunity for us to kind of produce an artifact here, which is can we start to capture somewhere together just our experiences, like, oh, for this vendor and this hardware, it has to be done in this way and this one in that way, and see if we can come up with a sort of matrix of here's the order of operations for these given fingerprints of hardware. I think there would be some really interesting opportunity for conversation on that, and see if we can, because that's something we need, for example. And right now, that's kind of what I'm most interested in, is how you can all help me with my problems. Yeah, which I'm sure that's all of your primary interest as well. And so I think this would be another thing where we could reach out, maybe see if other people are interested in talking, and maybe this is something also for the large scale SIG. And I kind of want to roll past that and look. I think this sort of ties into one of the next things, which is we talked about, okay, we're going through, we're updating firmware, and we're reasserting hardware as safe for use. And part of that is actually running the risk of, if somebody's installed compromised firmware on a host, detecting that and remediating that. Has anyone successfully built automation to handle that use case? Like really going through, inspecting the hardware and saying, like, yes, disk firmware has not been compromised. And to that end, actually, does anyone have any operational stories about encountering exactly that?
So, okay, first question, I don't have an answer to the second question, but my hope is eventually we have some sort of keyline integration where that entire process would basically flag the machine as being compromised by when it checks the checksums and the values, and measurement fails, machine's blocked, and at that point, cleaning's done. You need to go rip that machine out of the data center at that point. Unfortunately, we're not there yet, but people are working on it.
Cool, thank you. And then, so did anyone have any horror stories to share on actually encountering compromised firmware on their hosts?
I don't, but I would be curious to know, like, because I feel like you'd have to have such a commitment level to be able to actually go as far as like reverse engineer a whole firmware and make it functional for that system, but also do whatever you're trying to accomplish maliciously, I guess.
I have, they're not my stories to share, but I can give you I can tell broad enough brushstrokes for it that I think I can share.
Sure.
Not necessarily malicious, but firmware changes that are unexpected. So I think if you step back from the malicious attack and just assume that if you're giving people a piece of hardware and they have to make a change to it in firmware, that is very possible that somebody will change the firmware to meet their needs without telling you. And so from that perspective, that's something you have to be prepared for. I think there's a reset of firmware and validate the firmware if you can trust that somebody didn't put something malicious in it. As soon as you assume it was a malicious intent, even the checksum validation, I think, can become tricky.
Yeah.
From that, because the vendors aren't really building tools that stamp the firmware that I've seen. I'd love to know if they do. Maybe UFI has some capabilities to checksum itself that I'm missing.
So a lot of the firmwares actually will give you a checksum. The downside is that the way it works, as far as I know, is you're actually querying the firmware and it just tells you what the checksum is, which means Ava, did you want to jump in on this one? I see you raised your hand.
Sure, I'll take that one. Without having an out-of-band mechanism like a TPM that can measure the firmware signatures, the firmware checksums without really powering them on, like Rob was starting to say, you do rely on each firmware, each microcontroller to tell you itself what its checksum is. And it's been demonstrated for several years now that it's quite possible to make them lie.
Mm-hmm. Yeah, and that's exactly the thing I was kind of wondering at, is if someone's figured out a way of doing that.
Oh,
But
yeah.
it sounds like what you're saying is actually doing some more work, some of this pre-work with a TPM, it's actually possible to position things. And then I guess that makes sense that if you have signed kernels and you're doing some other, maybe others measured boot things, you can actually put the machine in a state where it's much harder to use like a rootkit or something to go and actually change the firmware on the host.
Precisely. If a malicious actor is trying to use a kernel that contains a rootkit, you need the trusted boot to verify the kernel. But to have trusted boot really be trusted, right, the attackers moved down a layer and began finding ways to compromise the firmware, whether it's the boot firmware or some microcontroller on the board or a SATA device or a USB device. There's lots of tiny computers in our computers.
Right.
And verifying as much of that as possible. And Intel began to do and publish a bunch of this work circa 2015, 16. Talked about it at OpenStack conferences back then a little bit. And the work's still ongoing. Multiple vendors have stuff going in that space right now. But it's always some sort of an add-on chip or add-on card to do the out-of-band measurement of the firmware. Without that, it's kind of futile.
I believe TPM v2s are supposed to be able to do the out-of-band measurement of the firmware, but I think the conundrum is that I don't think they halt by default. I think they just changed the returned register.
Yeah, I believe you're correct.
So this is actually something that'd be really good to add to that TPM thing, which I'm collaborating on that list above. And just as a reminder for folks, if you're interested in collaborating like SOPs and docs for managing keys on a TPM and provisioning TPMs and sort of the whole life cycle there, in both in large data centers, but also in smaller deployer environments. If you look up on line 200, there's a currently list there. So please add your name and email so that we can circle up and start to talk about that.
Yeah.
And thanks for sharing that, Ava. I really appreciate that.
That's good points.
And so kind of moving on here, we actually sort of jumped ahead, which is really good, I think. So we talked about, what, are people doing periodic updates of firmware? And the answer is sort of like, yes, but, it's quite complex. And so there's, I think, some opportunity for us to talk further there in the future. Revalidating hardware before returning it to the pool. We touched on that. Someone as a reminder to set your BMC firmware control passwords. That's an excellent point as well. Actually, this makes me want to throw in another question for those of you that are doing that are using things like IPMI or Redfish. The security for IPMI leaves something to be desired. Something we do is we actually have IPMI is actually on an air-gapped network, and that's something that you're going to have to tie the conductors into for if say you're using Ironic. That's something we do. I'm curious if anyone else has any other examples of things they do to secure IPMI in their network.
Yeah, it's something similar on our side here, which is, put IPMI on its own, as far away from everything else in the world. And kind of that's like step 0 to ensuring that it's all secure. I guess the other kind of concerning thing that can happen is, I know some devices allow you to disable the host of configuring anything inside the IPMI config. And so that's also useful to do if the hardware supports it, so that you don't end up in a machine that's like unmanageable because someone ran something and changed the IPMI password, and now you're like, you can't manage that host anymore.
Right.
I think one thing beyond disabling the host access, I think at least moving forward with Redfish, the fact that we're now starting, or we should by spec be getting a network like make TCP connections to the BMC sort of access. And if you think about most BMCs, they're basically another small computer that runs like Linux that could be compromised potentially. So we're actually creating a whole nother attack vector by improving the manageability of these machines.
Right. Yeah, that's a good point. And Rob, to your question on the chat, for ours, it's actually, it's basically bridge. It's physically a separate network, but certain machines have second interfaces on it, like our Ironic conductors.
That's what I was. Air gapping for us means there's no network access at all. So yeah, if the server, if the provisioning control has access, the thing that, which is what we'd recommend always, the challenge becomes if you want actually console access through that network, then what you've now done is now you need a proxy to forward to that. And I haven't seen a good proxy IPMI system like that. It would be really nice to be able to see a proxy, a proxy for IPMI, so that, or I'm saying IPMI, but I mean console, IP console, so that you could then provide controlled access forward from a control point. That would be a nice add. Like we have all the data to do it. I just haven't seen anybody with a nice utility for that. I know Packet has something internally, but I haven't seen how they did. I haven't seen the source code released on that.
Mm-hmm. Yeah, I want to talk to the team we have that actually runs a console reader, a serial over LAN, basically access infrastructure. So we run on, there's another set of hosts that are also bridged into this IPMI network, and they run a program that connects to every serial console for every machine in that data center, or at least it's a subset, because we actually have scale issues, so we actually have to have multiple of these machines now. But the way it works is then they have an API set up, so folks that are in the approved access list for that given machine, based on the property of the application owner that is using that machine, they can run a command from their laptop, and it actually sets up a TLS connection to one of these API proxies. And then the thing that's running in the background that's connecting to all the serial over LAN, it's actually logging everything to a file. And so when they connect, it replays the last n lines of the log, so you get some context of what's going on. And then you could just log in and do things from there. It's pretty useful. It manages many tens of thousands of nodes per data center. So I think it's pretty cool. I want to ask the team if they're willing to look into open sourcing it, because I haven't personally seen anything yet that operates at that kind of scale, but I think it would be pretty cool.
That would be pretty cool. I know there's been some talk of similar things in the Ironic community, considering we do have things like the SOCAT console proxy, but something with logging is definitely something that a lot of people would take advantage of, because that gives you a lot of insight and even allows like things like bare metal CI to be much more effective. Especially if your machines don't boot. Oh, I can see why it didn't boot. Okay, now I know what to do or can't do.
That's a good point. Yeah, if you're doing, because actually that's an interesting point, because one of the other advantages is if you're doing inspection and you run like some hardware burn-in stuff, like an example could be if you just sort of relentlessly run ubench every time and this sort of moves us to the next step in like the day-to-day hardware lifecycle. Whenever you re-inspect hardware, like after someone deletes an instance, something I want us to do is start re-inspecting the hardware and actually do a check of the CPU, memory, and disk. If the memory is bad or CPU is bad, in some circumstances it's detectable, and you can just send it. You can just send a message from the instance to Ironic to notify it. In other cases, if you hit something bad, the machine just crashes. So that's a case where it'd be really useful if there was better tie-in between Ironic and a serial console to actually capture that output and say, hey, I was running inspection, I was testing the memory, the machine crashed, here's the last thing I saw before it horked. And that way there's like some more usable information that goes to the operator, as opposed to, the machine died while testing memory, you're gonna have to go look at the console yourself and figure it out, go dig in, as opposed to auto-creating a ticket with the relevant information. That would be something I would really like to see. So moving on to, we talked about like day-to-day, the firmware management, and there's a lot of opportunity there. We talked about some of those other pieces, and I feel like there's a good opportunity here to talk now about sort of the larger picture. Earlier Mohammed talked about data center management stuff, and one of the things I think then that's part of it is, once you're running, you have machines deployed in a data center, there's some larger problems that come down to do with like thermal and power management. And so one example is detecting hotspots in a data center. Is anyone building or running any automation that helps detect hotspots or in a data center, and to allow you to go, and if you're doing hot cold rows, like move some floor tiles around to try and balance things out. Or even the next step from that would even be, are you doing anything to detect this and even shut some workloads down in some parts of the data center and power them up in other parts of the data center to balance things out?
Well, I'll go with what I did years ago, which was I just kept the thresholds on the out-of-band sensors ridiculously low. So if air intakes hit like 90 or 80 or something like that, I don't remember exactly what it was, then I would get a warning. I wouldn't actually have that warning trigger page, but it would give me enough information if I loaded the status console and go, oh, I've got 6 machines in this rack that are warmer than the rest of the data center. I should probably go look at that and actually reevaluate the airflow. But definitely not a tooling to automatically go, oh, I should probably start shifting the workload around.
Right. Which makes sense, because back then that would have been pretty, that would have been a pretty uncommon use case anyway, is actually automatically moving the workload. Something I'd done in the past, I mean, it's so long ago, is written in Perl. Is I wrote something that was actually going through one of our smaller data centers, and it was querying all the smart PDUs and just asking them what their temperature sensors saw. And then it was taking that information and put it into a database, which also meant it captured the power draw from the PDU, which was useful as well, because we could detect which PDUs were overloaded. And if you've ever had to like go and install loose gear in a data center, it gets to the point where you're doing the math and calculating how many watts are actually being used in a given rack, to see if you can sneak another machine in. So it record all that, and then the heat information went to actually a heat map of the data center. So you could look and say, you just glance at a map and say, oh wow, this row is starting to trend red. We should do something about it. That was one of our older data centers that was kind of a traditional hot cold row design. So I don't know if anyone else has built anything like that, but if you have, I'm guessing that folks would be pretty interested in that. I believe now our team that runs our data centers, what they're doing is they're actually pulling IPMI on host to get the same, at the very least, the same thermal information. So that way you can just query every machine, see what the temperatures are, and from that they can start to get an idea of what the, where things are in the data center.
One thing that we have in Ironic is we have the periodic sensor data collection, and that will include the vendor wired sensors that are in the BMC for things like fans, temperature. That way it can be reported back, and you can potentially grab that data out of the data stream and present that to a user or to Logic and leverage it.
Yeah. I didn't even know about that. I'll need to talk to my team, because that might be something in the long run. The team that's currently gathering all that data, they might want to switch to just using the Ironic API to fetch that. I think we have to upgrade our version of Ironic to get there, though.
The sensor data collection's been in there a long time, and the data collection's not exposed via the API. It's exposed via either a Prometheus exporter or via the message bus.
Gotcha. Okay.
Something that we do is, given that we run the hardware exporters, a lot of the systems will usually have inlet like air temperature sensors and outlet air temperature sensors. And so we rely a lot on those, and not as much of a rack level probe, but kind of a server level probe. We also set up alerting that's based on the limits that are published also by the exporters. So different machines obviously have different temperature limits for their inlets and outlet temperatures. Like for example, the GPU heavy machines that have the GPUs in the front, their inlets need to be a lot lower than the normal machines that will take like room temperature going in. And so that's an interesting thing that we do on that. Also, I'm interested on that same subject is on, you mentioned you kind of have an older, some of the data centers are more old and traditional, like cold aisle, hot aisle type of thing. But has anyone worked with any facilities that are doing anything like, having the entire data center in ambient temperature and having these like really thick doors in the back that are kind of have big radiators. So you stand behind them and there's just cold air coming out of these racks if the door's closed, obviously.
Yeah. We actually build, that's how we build our newer data centers now. If you look up the Verizon Media or Yahoo Compute Coop data centers, so this is all public information, there's some really cool infographics that'll do a better job explaining this than I can, but they're really interesting because they're built around the idea of passive cooling. So the whole data center is built sort of like a gigantic chicken coop. It looks like a really big barn, basically. And so there are louvers on the outside of the buildings that air comes in through. And one of the parts that I find most interesting is that all of our compute nodes are, they're in cabinets, and the cabinets are assembled together in pods, and the pods are actually sealed. So the servers face outwards in the pods, and then air is drawn in through the front of the server, then exiting the rear. So what this means is that there's a higher pressure zone inside of the pod, which is then ducted up to this cupola in the top of the building. So there's a convective cooling effect. So this means that the servers are the air pumps that are driving air out of the data center, and so which means that those are helping pull air in through those passive louvers on the outside of the building. There's also membranes there behind the louvers that can have water pumped in them for a swamp cooling effect to help chill the air intake even further. Now, the interesting problem here is that if we turn off too many servers in a pod, we can get to the point where there's no longer enough air coming in to maintain that high pressure zone. And so what can happen is that air can start blowing out backwards from the powered off servers, which means that if we turn off too many machines, we can actually cause an undesirable thermal event. So we can actually cause the air in the rest of the data center to get a little bit warmer. So there's some automation that our site ops automation team has, our data center automation team has, that actually goes through and examines the thermal state of the data center. And there's lots of really cool stuff that's happening that's controlling. The louvers are all automatic, and there's a whole control brain to the whole thing. But in addition to that, this site ops team, what they do is it automatically monitors when one of these pods has too many servers turned off, and will actually turn some back on just to go and act as those passive fans and help balance the cooling in the data center. So it's interesting that we manage cooling in our data center partially by turning machines back on.
Now, are those machines are you using a sort of power saving with those machines on, so that just the fans are running?
Yeah, so the answer is no. Right now, what we're doing is we're actually just putting an OS on them and we're leaving them up and running. But that's actually a problem for us too, because let's say that there's another shell shock or something. This means that our security scanning picks up these machines as being like, hey, you need to go turn these, you need to go upgrade this, whatever bash or whatever, or sudo or whatever it is on this machine. And that's just like a lot of work for us to go and basically upgrade a package on a machine that really is just an inventory node. So one of the things we're looking into now is, can we just wipe the drives entirely and just let them, is that going to be okay if they just sort of go through this infinitely long booting process since they won't have an OS on them? Or do we need to put an OS image on there that's crippled? So it comes up, but it's on one that's like crippled in such a way that it has no network access.
It could be interesting. I guess if you are putting an OS on it, you could at least use it for other workloads, maybe.
That's actually something we've been talking about, and I think that what I was going to bring up when we talk about this actually, and I think Julia, you're moderating this one, right? We're talking about containers in production on, was it Thursday?
Tomorrow.
Tomorrow, yeah. Thursday, Tuesday, it's all the same. Yeah. So I think this is that. I think we've had teams ask about that I'll want to talk about tomorrow for sure. And so I think if other folks are interested in that, definitely make sure to tune in for tomorrow's session as well. Good. Does anyone do automated management of like power loading. So the same thing, like detect where there's power availability and moving workloads around in case of like, oh, this PDU is overloaded. Let's actually get things turned up over here instead.
We don't, but our power circuits are kind of pretty over provisioned, and luckily we have a lot of power in it's all hydroelectric here. So usually power is pretty easy to come by on our side here.
So I think what James's point is kind of driving the discussion towards is when you have a transformer and you're loading one side of the transformer, you actually lose a lot of efficiency because you've lopsided the load on it.
Exactly.
I haven't seen the use case you're describing, but much more dynamic operational control for the provisioning I do see. But it's the reasons are not as, I haven't seen it based on temperature or load specifically. But I mean, I think it's a general, you're talking about a general use case with a specific use case with a general solution, a generalized solution, because once you can do that, it's really just a matter of what you're using to trigger the migrations or changes.
Right. And
I think a lot of it ties back to your hardware inventory, because in order to know, you have to know what PDU and what transformers the machines are powered from in order to go, oh, I can turn on machine set C, but not machine set D, because that will lopside in the other direction. I don't want to do that. I need to target this one specific area. And without that power information, I think it's kind of difficult, but it's definitely a good problem.
Would you drive that from like a CI automation, or would it, I guess it depends on what's making the requests.
So all right, go ahead.
I think you'd have a monitoring system that would be evaluating, that would have to look at each layer of the data center power inflow. So you'd have to go all the way from the entrance, transfer switch, UPSs if you're there, transformers, and then there has to be enough correlating information to make it all the way down to the PDUs to be able to balance that load out. And then you have to be able to graph it and just somehow correlate that and display it and allow logic and humans to make decisions from there.
Yeah. So actually what could be interesting, and Julie, what you were saying kind of made me think of this, is and something that one of our data center automation team had mentioned is that, they had mentioned marking some machines in Ironic as unavailable for use. Basically, if those machines were on a PDU that they thought was overloading. But what occurs to me is there could be some interesting opportunity for dynamically, as something is scanning PDUs, it could be updating something that is then used to weight scheduling decisions, which already there's a lot of advantage to that because something our users really want. And I think this sort of is a tangent of something that's important to us is they want anti-affinity by power domains. So they want to know specifically that their hardware is striped across multiple PDUs and in some cases even multiple generators, right? And it really comes down to like the use cases. As a user, I want to know that if there is a rack switch loss or even a PDU loss, I want to ensure that if I have 4 racks of gear, that I will only ever lose, or I will be highly unlikely that I would ever lose more than one entire rack at a time, so that I can ensure that at least 75% of my instances are still up and running if that happens. Is this something that's interesting to anyone else? Because this is something our users have been asking for a lot, and I'm just curious if anyone's made any headway.
I'll let somebody else talk, but I have an answer also. Somebody else was going to jump in. Okay, so
it might have been my cat.
We've been adding a pooling capability, which adds, instead of working with machines individually, you can basically say, give me a machine from a resource pool. And what you're describing sounds a lot like some of the use cases for that, where you could come in and say, you know, these machines are in a distributed pool across multiple PDUs, and then take them out or ask for machines that are in different PDUs. So rather than dealing with provisioning operations as a specific machine, then you're saying you're asking the system for resources that match a resource pool or some type of filter parameter from that perspective. And then you would have the ability, and then from there it kicks off a workflow and you get the machines in whatever target state you want based on the input values. And so from what you're describing, it sounds like this, and this ends up being a question to me, because what you're describing sounds like a resource pool where you can selectively move machines. Because the number one, to me, it's, yay, I need to be able to pick machines, but I also need to able to release machines and have them not in the zone where they were, or if they disappeared, come out of the system. So you sort of have it's a pooling behavior. Is that sort of what you're asking for?
Yeah,
It's not the use case I was imagining when we were doing this, but it's a good use case.
Yeah, I think that's kind of it. I think it is certainly related to that. Yeah, like some kind of pooling behavior, and it's really about establishing, like you said, like pools or puddles or just having some specific like depth of anti-affinity domain. And in some cases, even affinity domains. We were working with, so J-Pipes was working on something for a bit, and it didn't get past the blueprint stage. But if there's other folks that are interested in this, I think this would be, a useful thing for us to talk about too in the long run. Sorry, my cat keeps nuzzling my laptop.
I think that would be a good topic for the bare metal sake, at least to maybe consider and look at ways that we can make it easier to help manage those loads, or help provide some sort of integration point, even if it's just go check this other thing and do power actions based upon that.
Right.
Because we could definitely leave machines on with boot to network and not actually have network configuration, if that helps.
I'd say +1 for me, James, on being interested in, well, the idea that Jay spoke about before. So I think he had this quite nice concept of trying to describe distance. So within the hierarchy inside placement.
Exactly.
Some of those bits in placement are a bit further along now, so it might be easier because there are nested resource providers. So it might be you can model it in that, although the requests get horrendously complicated. But
right.
I think it's the same problem people have with VMs, because it is the solution of AZs, but it's always too coarse.
Yeah, and that's actually exactly one of the problems we have. Is that we're looking at AZs in our newest cloud environment, but it's just, even then, we're trying to encourage people to operate in a very cloudy way in this newest environment, but still for them, AZs can still be far too coarse. An example, one of our applications that's a very large property for us. They run like kind of a well-known application. One of their parts of their environment, they can only lose like 1 out of 48 machines or something at a time, or like 5 out of 48 machines. I forget the exact number, but it's very difficult to give them that level of anti-affinity currently with just like random distribution of hardware. And I think there's some opportunity here then, if we have this other element that's able to weight things, is like, okay, yeah, let's strike them across 5 PDUs, but avoid this one because it's getting kind of hot. So let's just sort of send workloads elsewhere.
It almost seems,
sorry. Go ahead. We're actually at time, but Julia, go ahead and say what you're saying.
It's almost like we need the ability to do a generalized weighting system so that you can start deprioritizing areas of a data center based upon external data and input. And that may not be anything you have to actually make the scheduler aware of, other than user preference of scheduling over in this direction. And then you need something that's way smarter, that has a lot of the grouping information to be able to do the affinity or anti-affinity.
Yeah, we should definitely go through that at some point, Jay's original idea, because it had a lot of the building blocks of that description.
Yeah.
I should dig that up.
Hey, I got a question about your racks. You said you had to leave the machines running to control the pressure of the airflow. Have you ever considered putting a sheet of plastic across the front of those machines that were not used to prevent the airflow going through them? Just like a spacer in a rack, you know, for the blank spots. I've never
That's
had the
actually what we
fortunate problem.
do.
It's just a piece of plastic, but the problem is that after a while, you got to replace that plastic.
Yeah. In fact, what we do is actually for empty spots in racks, we actually have metal blanks that we put in.
Yeah.
That are like 1, 2, 4, 6U. The problem is when machines are turned off, then air is blowing the other way. And we talked a little bit about like louvers on the backs of machines so that when the pressure wanted to go the wrong way, sort of like a check valve to stop air from going out the front of the machine. But it just, in the long run, building things that way to have a set of like shuttered louvers sitting over the back of every machine that would just drop in place and sort of seal if the machine was powered off, ended up being less cost effective, I think, than just turning some of the machines back on.
Okay, and then another thing that's like maybe I missed in the point earlier. Every data center that I designed with the racks, I always had 2 separate power supplies coming to every single rack, and then my PDU bars all had amp readouts on how many amps were being drawn on each bar. So, but the business investment of automating all that versus just walking over there and looking at the LEDs when you're building it and kind of balancing the rack, we never had a need to go back to make an adjustment on those. It was mainly the racks that you had weird pieces of equipment, and it wasn't a rack that just full of what we call pizza boxes. You know, it's weird equipment that we always have to balance. The racks that were full of pizza boxes, we just did the math on the number of amps and made sure that we could control full load for all the servers. So I was just curious. And the temperature discussion was, I've had temperature drops and we've sent people over to the data center. What the hell is going on? It was a small system, and every month it would happen, and we finally figured out, that's the AC guy. He's shutting off the blowers and he's replacing those filters, and the blowers are down for like 2 minutes, and then he's gone, and then we go in, and so we finally put a camera in to find out why the temperature dropped. Why the room got hot. And the racks that we did have issues with, we had a little temperature gauge on an Ethernet cord, and we dropped 2 or 3 in, one at the bottom, one in the middle, one at the top, to try to adjust the airflow on the box, and then we move it to some other place. But anyway, before you left, I just wanted to see about that.
Yeah, thanks for sharing that. That was actually pretty cool. Thank you.
Sure.
Yeah, and so actually we're about 4 minutes over time, so I think we're at a wrap. I believe Jonathan was going to jump in.
I am. I was actually going to ask Mohammed and you if you had any major takeaways from the day that you wanted to kind of highlight as we wrap up.
I can go first to give some time for James. So I think it was a really interesting conversation. We had a lot of different people chiming in from different scales of infrastructure. So, from a much smaller scale up to the scale of like China Mobile and Verizon and CERN. So it was really interesting to hear some of the different contrasts of how, certain individuals deal with, let's say, kind of off-lease hardware that you don't really have the privilege of having everything prepared the way you like it, to having someone at a different site scale where, like James, where he gets a printout of all the machines that are in this rack and they scan one thing and they know it's that, to a whole nother scale of China Mobile where they raise tenders and people go and accommodate for their needs, which would be really nice for all of us, but it's different cases for different environments. I think it was also a really good conversation towards the end where we talked about all the different platforms. and how to do kind of inspection as time goes by, and how things are changing always in a data center, and how to track all those changes. So that's sparked some really interesting conversation around Ironic and the features that it offers to do these things. And we got to hear from a lot of different perspectives from a different scale. And I think this was a really kind of interesting and productive conversation. We've got a really awesome Etherpad that's kind of an artifact of all of this discussion. And I'm hoping that we take a lot of discussion onto forwards to things like the bare metal SIG to continue to discuss some of these. That's mostly kind of for under the topics that we were talking about.
And for the bare metal SIG, that is generally coordinated on the OpenStack Discuss mailing list. Is that correct?
Yes. So I think we can actually quickly post a chat. So this is an Etherpad, I think, that is used by the bare metal SIG and the participants of it. So if you're there, I think that has a lot of the information, some of the meeting, and proposed goals and whatnot. So you can go there and reach out, or as well as participate on the mailing list.
Yeah.
One thing every week during the Ironic meeting, we try to have a checkpoint for the bare metal SIG. If there's anything we need to talk about or discuss, and that gives us a chance to bring those people together and with the Ironic community and just see if there's anything that we can do.
Okay, cool. And then James, you around, I think it was line 201 in the Etherpad, you were talking about a kind of an SOPs document for managing TPM. That's a lot of acronyms. Yeah. We need a document to define the acronyms too. But that seems like something that a handful of people were interested in. Mark and Julia mentioned the bare metal white paper earlier, and I think that getting these real world experiences that people have and being able to write them down for reference ends up being something that is super useful and sometimes overlooked in open source communities. So if anyone else is interested in joining that effort, feel free to add your contact info into the Etherpad there. Are there any other things like that you think, James, that are good next steps?
Absolutely. Yeah. In fact, so that was one of them, certainly collaborating on TPM programming and sort of best practices and SOPs. Another thing is making sure or gathering folks that want to work together on grabbing the power affinity grouping and weighting stuff. So that's actually down in line 238. So go ahead and put your names in there if you're interested. And then the final thing I thought that was really interesting, we didn't put a spot in the Etherpad for this yet, is the larger problem of how do we capture for doing firmware upgrades, is there a place that we can all start to collaborate to capture both the method on a per vendor, per platform basis, as well as any other useful information or starting points on just like known good or bad firmware, like this vendor, this firmware for this, for like Linux kernels 3.10 and above, there are some issues and some gotchas to be aware of. Just because right now all the different deployers out there, large and small, are all actually going and replicating this effort over and over and over again. And if we can find a way to sort of centralize that, maybe we can start to get some good, get some use out of it.
Okay.
And I see that's happening. It looks on line 213. I can go and I can typey that and just capture that a little bit, and then put another opportunity for people to list names. Yes. See if folks want to self-organize.
Okay, great. Well, we will wrap today up. I'm gonna pass it to Ashley to kind of close everything out and tell us the plan for the rest of the week. So take it away, Ashley.
Cool. Great summary, y'all. Thanks so much for doing that. I enjoyed that. I learned a lot. So yeah, everybody make sure to come back tomorrow. We'll be talking about consuming bare metal for provisioning cloud-based workloads. We'll cover everything from hyperconverged workloads to serverless to some security and auto-scaling, preemptible bare metal. So Lots of topics tomorrow, so make sure to come back same time, same place. Then Wednesday is obviously networking. So yeah, make sure to do that. And then we're also going to drop a quick survey that it's, 2 or 3 questions, super short. We just want to get an idea of what you all are most interested in talking about for those topics tomorrow. So just go in there, check off a couple boxes of what you are most interested in discussing tomorrow so that our moderators can kind of help direct the conversation to make it the most beneficial for you all. So please do that before you duck out of here, and then we will see you all tomorrow.
That's it. Have a good time with OpenDev. Thanks, everyone.
Thanks, everyone.
Thanks.
See you.
See you tomorrow.
See you
Bye.
tomorrow.
Nice to see everyone again.
Thank you.